Hi guys, Lever here from Bright Young Brains. In this video, we are going through the entire November 2022 exam, which was written not so long ago, but it all depends on what time you're watching this video. But anyways, let us just dive into it, starting with the statistics question. Question number 1 here says, a metric class of a certain high school had to vote for the chairperson of the RCL, which is the Representative Council of Learners. And then it says here the scatter plot below shows the IQ, which is the intelligence quotient of the learners, of the 10 learners who received the most votes and the number of votes that they received. So let's see different IQs here from low values to high values. And then it says before the election, the popularity of each of these 10 learners was established and a popularity score out of 100 was assigned to each. The popularity scores and the number of votes of the 10 learners who received the most votes are shown in the table below. So let's see here. The first row, it has the 1, 2, these are 10 numbers. These are probably, this is the popularity score. And then here the number of votes that each of the learners got. And then the scatter plot has information about the IQ, so we shouldn't get it mixed up. And then it says here for 2 marks, calculate the mean number of votes that these 10 learners received. So mean, it means that you're going to have to add up each of these numbers. The votes. So you have to add up each of these values and then you have to divide it by 10. So it's going to be 9 plus 22. Let's see here, make this a bit bigger. Plus 10 plus 21 plus 11 plus 15 plus 20 plus 12 and then what else here, plus 19 and then plus 16. So all these values, you're obviously going to put that in your calculator, divide everything by 10. Let's see what we get here. At the top it's 155 divided by 10. This is giving us 15.5. There we go. And then let's see, what else do we have here? The next question though, that's what it's asking us. The next question is asking for the standard deviation. Oh yeah, so I think from the get-go, it may be just easier for us to just put the data into the calculator. So putting the data into the calculator, we obviously are going to need to press mode, and then we're going to need to press stat. So let's say here, mode, and then we're going to press stat, and then we're going to press var, which is option number 1. And then obviously we're going to get a table that comes out where we're going to need to insert the data in our calculations. But in this situation, you may be thinking to yourself, since there are 2 sets of data, why don't we just put 2 sets of data in the calculator? But let's see the rest of the questions. Let's see here, standard deviation of the votes. Let's see here, the learners who received the less votes, blah, blah, blah. Determine the equation of the least squares regression line. So since here they're eventually asking us for the equation of the least squares regression line, it kind of makes sense for us to put both sets of data into our calculator instead of like just one, and then now we have to worry about the other one. So to put both sets of data into the calculator, we're going to need to press shift and then the shift mode. No, it's still mode and then stat, but then we press number 2. So let's do that, mode, and then we press I'm gonna head out here, mode, and then stat, and then we press the second option, which is a plus bx. There we go. So the 2 sets of data that we're going to put in, it's obviously the 2 tables, the sets of information here. So this obviously you can see they've labeled it x, meaning it's going to go in the x column. There's labeled this y because it's going to go in the y column, because your 2 columns, they look like this. There's x here, there's y here. There we go. So if you're going to get the standard deviation of the votes for the 10 learners, let's put in this data first. You see 32 equal to 89, 35, 82, 50, going on and on and on. So as you're going to be putting in this data, obviously, the one thing you can just keep in mind is the only way you're probably going to get some of these questions wrong is if you don't put in your data correctly. So obviously, after putting in all your data, you want to just double check that you've put it in correctly. So here we have 22, then we have like 10, 21, 11, 15, 20, and then 12, 19, and then 16 is the last one there. Everything seems like it's all good. So you're going to press shift and then the number 1 button. Yeah, so after doing all this, right, you're going to press shift and then the number 1 button. So it's like shift, and then you're going to press the number 1 button like that. After pressing the number 1 button, what's next? Let's see. After pressing the number 1 button, you're going to press 5 for reg. But then, bro, we want the standard deviation, bro. Come on. Come on. We have just put in the data in the calculator, right? We still just want the standard deviation. But we want the standard deviation for the number of votes. So to get the standard deviation for the number of votes, you're going to press shift stat, and then you're obviously going to click on var. So let me just write it out here. Shift stat, which will be the number 1 button, and then you're going to click on var. There we go. So after clicking on var, you're going to now need to think to yourselves, okay, for the x values, it's for the popularity scores. The y values is the one for the votes. So you're going to click on the one that looks like this. Then it has a y here, which is option number 6. You see, so after clicking that, it's going to give you the standard deviation, which is going to be rounded up to 2 decimal places. It's going to be 4.59. So all that being done, let's move on. It says the learners who received fewer votes than 1 standard deviation below the mean were not invited for an interview. How many learners were invited? So they said here the ones that received fewer votes than 1 standard deviation below the mean did not receive an invite. So what that means is you have to take your mean, right? You have to remove 1 standard deviation. You see, you have to remove 1 standard deviation. They say here, learners who received fewer votes than 1 standard deviation below the mean were not invited for the interview. So what you have to do in that situation is you have to take your mean, right? And then you have to add your standard deviation. So let's see here. Learners who received, so we're talking about the votes now, you see. So you have to take the standard deviation of the votes, add it once. So the mean for the votes, remember it's 15.5. And then your standard deviation is 4.59. So you're going to take those two, you add them up. You're getting the, no, you have to remove actually. You have to take the mean and you have to remove 1 standard deviation. The reason you're removing 1 standard deviation is because they said learners who received fewer votes than 1 standard deviation below the mean. So it's 1 standard deviation below the mean, you see. So you have to take the mean and you have to go 1 standard deviation down, which is going to give you 10.91. So what this means is any number that is below 10 point, what you may call any number that is below 10.19, 10.91 is not going to be, let's see, learners who received fewer than 1 standard deviation below the mean were not invited. So people that got lower than this were not invited. And then here it says how many learners were invited. So the learners that were invited, we have to pick out learners that got above this value, obviously. So in that situation, let's see. There is how many learners that got above 10.91. So there's basically 1, 2, 3, 4, 5, 6, 7, 8. Seriously? Seriously, bro? But then let's just take this nicely. Learners who received fewer votes than 1 standard deviation below the mean were not invited. So an interview, yeah, if it's below the mean, we only have to consider ones that were below that value. So it means that the people that were invited is 1, 2, 3, 4, 5, 6, 7, 8 people. 8 learners were invited. 8 learners. The reason why we're saying 8 learners is because if they had said the learners who received fewer votes than 1 standard deviation from the mean, if it was, let's say, 1 standard deviation from the mean, then we would need to, let's say, remove 1 standard deviation, get a number, and then we would need to like add 1 standard deviation and then get a number. And then what we would need to do is we would need to look for all the numbers that would be within the space from this to whatever this number would be. All those values between this and that, we know that those are the people that would have received votes that are 1 standard deviation from the mean. So if they're saying those people were not invited, it means that we would need to pick everyone that is outside that range. But with this question, it's quite straightforward. It's 8 learners. Let's move on. 1.3 says, determine the equation of the least squares regression line for the data given in the table. So the equation of the least squares regression line, you're going to say y is equal to a plus bx. Now, obviously, to get a and b, we can use our calculator. We have to say shift stat. So let's write that down. You're going to say shift, and then you're going to press stat. And then after pressing stat, you're going to press, so it's shift stat, right? And then you're going to press 5 for reg. So that's like reg. And then after pressing reg, you're going to need to press the, you have to get A first, right? So you're going to click on A first. And then after clicking on A, you're going to get the answer for A there. The answer for A is like 1.77, 1.77. You repeat the process, you choose B. Let's see what B is here. The value of B is, let's see here, shift stat reg B. It's like 0.22. Yeah. 0.22, excuse me. This is going to be 1.77 plus 0.22x. There you go. That's the equation of the least squares regression line. Nothing crazy, easy 3 marks. For 2 marks here, they're saying predict the number of votes that a learner with a popularity of 72 will receive. So remember, if you're going to have an estimated value for the popularity, it means you're getting a value of x. So meaning in your equation of the least squares regression line, you got a value of x and you need to get a value of y. So your y here, 1.77 plus 0.22, x value is 72. All this in the calculator. Let's see what it is giving us. 1.77 plus 0.22, 72. That's like 17 point something, but then 17.61 is, you have to round it off to 17. You see, the reason is you cannot have 17.61 votes. You have to calculate the full votes that you got, 17. So that's okay. Let's keep moving. 1.5 says, using the scatter plot and the table, provide a reason why IQ is not a good indicator of the number of votes that a learner could receive. Let's check the IQ stuff here. The IQ, let's see, people that got, it looks like here, depending on the number of votes that you have, you see here, the votes start from here going up, and the IQ starts from here going there. So it looks like the lower it looks like this here, the low IQ has low votes, yes, but then low IQ here also has high votes. And then here, high IQ has high votes, but then you have a situation here where high IQ has low votes. And then here, you know, average IQ has low votes. So judging from the scatter plot and judging from the number of votes that these people are getting. We can see that based on the question here, right? One way or the other, we can see that this scatter plot, if you were to draw some kind of a line of best fit, the line of best fit would almost be a straight line, you see. And what we know is, depending on the line of best fit, remember the line of best fit, usually it's either, if it's going to look like this, it means that your correlation coefficient is a bit high. If it's going to look like this, it's also high, but negative correlation coefficient. But then the moment there is something like that, you see, it means that the correlation coefficient between the votes and IQ is negligible. But I don't think negligible is the best word to use there. We can just say there is no correlation, you see, because if the correlation is not there, it means that it's also low and it's also weak. So we can say there is no correlation coefficient between, or rather, when you say no, I think no may be seen as a bit wrong. So let's just say the correlation coefficient between the votes is very low. Keyword very, because if it's almost like a straight line that you're going to draw there, it means the correlation coefficient between the votes and the IQ is very low. See, there we go. Now they said here for question 1.5.2, the prediction in question 1.5 is, what is the question now? Using your scatter plot in the table, provide a reason why the prediction in question 1.4 is reliable. What is the prediction in 1.4? The prediction in 1.4, why is this prediction reliable? Well, if you look at the votes and if you look at the IQ, let's see on the scatter plot here. The IQ, was it 72 was what? 72 was it popularity? I think 72 was the popularity, yeah. So the popularity score, if you think of something like 72, right? Roughly speaking here, around here, there's 79. This is like 19. So 72 and 17, those kind of have some kind of a link, one way or the other. So in this situation, you want to think to yourself, what is it that can be done to answer this question? The prediction, we have to give a reason why this prediction is reliable. So the reason why this prediction is reliable is because when you're looking at these two sets of data here, which is your two sets of data, that is the popularity and the number of votes, what we can already see is we can try to see the correlation coefficient of this data. So to do that, you're going to press Shift Stat and then Reg as usual. So let us do that. It's like Shift Stat and then Reg. Let's see here, 5R is like 3. The correlation coefficient there is like 0.98. So that's quite high, you see. So the value of R here is 0.95. So you can say here, the correlation coefficient is high, therefore the prediction is accurate. You see, correlation coefficient is high, therefore the prediction, let's see here, therefore the prediction is accurate. There we go. Therefore the prediction is accurate. Whew. Moving on to the next question. Number 2 says, a company conducted research among all its employees on what percentage of their monthly salary was spent on fuel in a particular month. The data is represented in the ogive, which is the cumulative frequency graph below. And then it says here, how many people are employed at this company? So let's see here. The cumulative frequency starts at 0, right? It goes all the way to 60. So 60 employees. 60 employees. And then that's just 1 mark, so that's fine. Second question says, write down the mode or class of the data. So the mode or class is where you see the biggest jump between one certain frequency and another. So obviously, from 0 to 5, the jump is from 0 to like somewhere there. So that's not a big jump. From here to there, that's not a big jump. From here to this dot here, that's not a big jump. It looks like the biggest jump is from here up until this dot here. And that's between 20 and 25. So the mode or class is between 20 and 25. So you're going to say here, x is bigger than 20, but smaller or equal to 25. That's going to be your mode or class, because that's the portion with the biggest jump, you see. And then it says here, how many employees spent more than 25 point, wait, how many employees spent more than 22.55% of their monthly salary on fuel? So what you want to remember is in the middle of all these or in the middle of all these classes, like here in the middle, you have 7.5 because it's 5 plus 10 divided by 2. In the middle here, you have like 12.5. And then in the middle here, you have like 17.5. In the middle here, you have like 22.5. So what they're saying is they want you to estimate the number of employees that have more than 22.5% of their monthly salary on fuel. So those people, it's going to be people that are from 25 going onwards to where the end is. The reason they're mentioning 22.55 here is because they're trying to tell you which class interval should be your starting point. So they want everyone above 22.55%. So those people, you're going to start here. You're going to need to estimate though. This value seems like it's in the middle here. So that's like 45. And then going up here to like 60. So you're going to say 60 minus 45. You're going to get there, I think about 15. 15, yeah, it's a 45. Well, one way or the other, we just have to be careful here. Well, no. We have to look at it this way. 22.55 is here. So this you can trace it to like somewhere there, which is like somewhere in the middle here. You can either predict 34 or 35, it's okay, because it's like relatively in the middle over there. But it looks like it's like over there, so it's like 34, because if I zoom in here, yeah, it looks like it is right over here, which is gonna be over somewhere there, because it's like 2, 4, 6, 8, 10. So that's like 34. So this is gonna put there 34. So it's gonna start here, right? And then all the way until like the edge there, which is 60. It's gonna be 34 over there, and then 60 over there. So let's see what that takes us. This minus the 34 is gonna give us a 60. No, 26. Goodness. Let's see, moving on. 2 marks, it says an employee spent 2,400 of his salary on fuel in that particular month. Determine the monthly salary of this employee if he spends 7% of his salary on fuel. So what we know is 7% of the fuel is equal to 2,400. So no, 7% of the salary is 2,400. That's what they told us, because they said here an employee spent 2,400 of his salary on fuel. Determine the monthly salary if the employee spends 7% of his salary on fuel. So 7% of the salary is equal to the fuel. Of means times. So this is going to be 7 over 100 times an amount that we don't know, equal to 2,400. This is going to give you 7x over 100, 2,400. Here, we're going to need cross multiply. So 100 times this is like 24, 40,000. This is 7x. Divide by 7 on both sides. What do we get there? 240,000 divided by 7. That's going to give us an amount of 34,285.71. Yep. So that's that. Let's move on to 2.5. 2.5 says the monthly salaries of these employees remains constant, and the number of liters of fuel used in each month also remains constant. If the fuel prices increase from 21.43 up until 22.79 per liter at the beginning of the next month, how will the above OGIVE change? So the thing is, you have to remember that since the monthly salaries remain the same, and then the amount of fuel used remains the same also, the one thing that's going to change is the percentage of the salary used, you see, because they're still buying the same amount of fuel. So if the percentage of the salary increases, it means that the OGIVE would somewhat slightly move towards the right. That's what your OGIVE would look like. It would almost seem as though this entire shape is like moving towards the right. But then in a situation like that, you see, it just means, remember, the reason why you to be moving towards the right is because the percentage of the salary is increasing, you see. So in this situation, you can just write what's on your mind, but it's an accurate description. You see, you can say here the percentage usage increases, right? So the OGIVE would appear to have been moved horizontally to the right. So us saying that it would appear to have been moved horizontally to the right, the one thing we want to take note of is that one way or the other, right, it would appear as though the width of this OGIVE would increase, because if each of these percentages here, if they go up a bit higher, so it's going to be these values moved a bit to the right, these values are all moved a bit to the right, but the OGIVE always needs to eventually go to 0. So the width would also appear to increase. So here the percentage usage increases, but then with that being said, it would appear to have been moved horizontally to the right, increasing the width. There we go. We can say something about the width of this OGIVE. So that's going to be worth 2 marks. Let's move on to question number 3. Question 3, analytical geometry. Finally done with the statistics, because statistics is a bit boring. However, I mean, you can always make sure you get all your stats marks correctly by just going through the statistics course on the website. It is going to take you about 3 hours to go through the entire stats syllabus. And even though it's boring, it's easy marks. So you might as well get those easy marks. Obviously, if you have any questions, you can just hit me up also. But anyways, the link to this is in description. Link in description. But anyways, I keep saying but anyways, but let's just carry on now. So here they say it, right? In the diagram, A, B, and C are vertices of this triangle ABC. They say T is the midpoint. Well, I'm just reading here, which is not good. You're supposed to read and you're supposed to refer to the sketch. So they say the vertices A, B, and C, right? So it's like A, B, C are vertices of this triangle. T is the midpoint. Where is T? T is the midpoint because you see this is equal to this. T is the midpoint of C. B, the equation of the line AC is this. So one thing you want to do immediately now, right, is you want to take this equation and you want to write it in standard form. So here you're going to have minus 6y equal to negative 5x plus 8. You're going to divide everything by negative 6, negative 6, negative 6. You're going to have your y is equal to 5 over 6x negative. This is going to be what? 2 goes into each of them. So if you simplify here, let's not even bother ourselves. This is what you're going to have as your equation of this straight line here. But I guess you can already see that this is the y-intercept, right? Negative 8 over 6. So we might as well simplify. You know, in the calculator, it's going to be 4 over 3. So 4 here over 3. What we do know is that this is like negative 4 over 3. Perfect. And then they say that the angle of inclination is alpha. Triangle DCT, D, where is DCT? D, C, and T is drawn such that these are parallel. So it's good to have parallel lines. And then, with all this being said, let's see what else they're telling us. They said here that the lines AC and DT intersect at S. So there's AC over here, DT over there. They meet each other at the point S. And then that's just them describing the sketch, nothing crazy there, nothing major. And then they said here, they intersect at S, right? The y-intercept of AC. Yes. And then they say here P, F, and R. There's P somewhere here, F somewhere here, R somewhere here. They are the x-intercepts of these different lines, A, B, D, DC, and there's also like AC over there. Yeah, there's no point there, so it means we might never need it. But these ones here that have been given names, we can just keep those in mind. But anyways, let's just move on to the questions. Get the gradient of AB. Very straightforward, very easy question. 3 marks, never lose those kinds of marks. So you can write out your gradient equation, put in your x and your y values, and then let's see what we can do there. Let's see here, moving on. So we can easily just say here negative 4 minus 2, negative 4 minus 2, and then 6 minus 4, right? 6 minus 4 is like negative 6, and then you have like 6 minus 4, right? Is like a 2. So we have here negative 3. That's the way we like it. And then one way or the other, that's just straightforward. Nothing crazy, nothing major. We don't even have to worry about that. They're asking for the size of this angle. Asking for the size of this angle, you can see it's a standard question. We can get this angle by working out the angle of inclination using the gradient of AB. You see, because remember, the gradient of AB will always be equal to tan the angle. So this is like negative 3 tan with the theta over there. And then you may be thinking to yourself, what? Really? But let's see. We have gotten the gradient of AB, right? They said we should calculate the size of theta. So calculating the size of theta, yeah. The thing is, if you're gonna use what you may call, let's just see what we get here. The thing is, one side is acute, the other side is obtuse. So whatever you do, here you have to get a reference angle by using the number 3. So you're gonna say shift 10, you put 3 as a positive number, because whenever you get a reference number, you always have to use a positive value. So shift 10 with the 3, you're getting 71 point something, 71.57. But then remember we said you have an acute angle somewhere and an obtuse angle. So the reason for using a reference angle scenario is because you get to see if you get an acute angle, it's this side, the obtuse angle is 180 minus this value here. So the alpha is going to be 180 degrees minus the 71.57. Let's see what we're getting here. 180 minus this answer. It's 108.43. 108.43. There we go. All this being said, I want the coordinates of t. So the coordinates of t, that's the middle of these two, nothing crazy there. It's just the straight, it's just the midpoint, it's just the coordinates of the middle. So it's like x1, x1 plus x2 over 2, y1 plus y2 over 2. Now all this, we can just say here x1, y1, x2, y2. So, oops. What is this going to be? It's going to be negative 2 plus 6. Let's see, they're negative 2 plus 6, right? Negative 2 plus 6 over 2. And then here you're going to have the negative 3 plus negative 4. Negative 3 plus negative 4. All this is going to give you the coordinates of t. So this is like negative 3 over 2. The other one, wait, negative 3 over 2. Bro, this is like negative 4, bro. No, positive 4 over 2. That's going to give you a positive 2. And this one is going to be a negative, you see, because plus and a minus gives you a minus. So this is like negative 7 over 2. This is your coordinate of t. And it kind of makes sense, but as you get it, you want to put it in your sketch. Let's just carry on here. Carrying on some more, right? We have the coordinates of s. So they want us to get the coordinates of s. Where is s now? S is this point. It's quite simple. The x value is 0. The y value, we got it by putting the equation of our straight line into standard form. So obviously, we have to show them that we know that the equation of the standard form gives us the coordinates of s. So what we did here to get the equation of our straight line into standard form, that's what you're going to need to make sure you showcase over here, you see, so that you can say here, therefore, s, the x value, you know it's 0, y value is just negative 4 over 3. 3 marks. 3.2 says determine the equation of CD in the format y is equal to mx plus c. So CD, fortunately, you already have its gradient because it's the same gradient as AB. So the gradient of CD is just a negative 3. You want a coordinate that the graph passes through so that you can put that into the equation of your straight line. You see, the equation I normally use is this one, y minus y1 is equal to mx minus x1. So the idea is our x1 and our y1, we have negative 2 and negative 3. You see, negative 2, negative 3. Gradient is like negative 3, x minus negative 2, y minus negative 3. So here you have like negative 3x. This is going to be a plus. So a plus 2 times a negative 3 is going to give you a negative 6. And it's like y plus 3. Negative 3x minus 6 is like y plus 3. And then you have here y here, right? Negative 3x. Negative 6 minus that is going to give you negative 9. Kind of makes sense because, I mean, like, this line seems like it's going down there, you see. So it's kind of accurate for us to be getting the answer negative 9 there. So it's okay. Moving on, let's see, calculate the size of DCA. Where is DCA? D, C, and A. So it's this angle here. So the one thing that comes to mind with a question like this one is, what is the mark allocation? Because the mark allocation gives an idea of how much you should think. It's a 4-mark question. And instead of us maybe needing to like scroll up and down all the time, let's maybe bring the sketch down here so that we can like see it nicely, you know. This is fine, this is fine. Let's maybe place it, yeah, over here is okay. So the angle that they're talking about, DCA, right? D, C, and A. This angle is in an awkward spot. But fortunately, this angle is alternating to this one. So don't take that for granted. The reason why you don't want to take this for granted is because it seems as though your life is going to be a bit easier working with this side of the sketch because we already have this here, cent 1.75. This we have it as 108.43. So you have this, you have that, right? And then the fortunate thing is, remember, what we do know is an exterior angle of a triangle is equal to the sum of the opposite interior angles. So what we know is the 108 is equal to these two combined. So we might as well get this angle of inclination here, because the moment you have this angle of inclination, You can actually also even just say interior angles of a triangle. Remove these two from 180 and get this angle. The moment you get this angle, you also get this one. So this is to also highlight that depending on what angle you're asked, you don't necessarily have to focus directly on that angle, you see. So let's get this angle here. We can name it AFR. So before we can worry about angle AFR, we have to get the gradient of this line here, the line AC. Because if you want the gradient of the line AF, you can just use AC because it's the same line. You have coordinate A, you have coordinate C. So let's get the gradient of AC. To get that, we're going to say 2 minus negative 3, and then 4 minus negative 2. It's going to be 3 plus 2 plus 3, which is a 5, 4 plus 2, which is a 6. So all that being said, you can now just use it to get this angle over there, right? So you're going to say here tan, the angle AFR is equal to the gradient, right? Which is like 5 over 6. So because you want to get the angle AFR, I'm going to say shift tan. Let's see what you get here. Let me see if I remember to write the shift 10 stuff properly. Yeah, I didn't. I should have done that. Oops, excuse me. I don't know why that just came into my head. So interesting. But anyways, shift 10 and then 5 over 6. So let's see. In the calculator, since we're doing statistics, right, you would need to make sure that your calculator is properly like cleared, but we already did that. 5 over 6, shift 10, 5 over 6 is giving us 39.81. 39.81 is over here, right? 39.81. Now, obviously, the fortunate thing is we can just put all this into the calculator. Let's put everything into the calculator and remove it from 180. So let's see here, 180 degrees. So let's see here, this is AFR, right? Here we want angle A. So angle A, maybe go to 180, minus 39.81, minus the 71.57, 71.57, right, 0.57. So all this being done, let's see here, 180 minus that value minus 71.57. That's going to give us 68.62. 68.62. And then here you can say angle A is equal to the angle that they're talking about, DCT, right? DCT, the reason is alternating angles. Therefore, DCT is also equal to 68.62. And you can see why these are 4-mark questions, because they expect you to take about 4 minutes to work them out. They expect you to already know what to do, which is very important in your exams. You see, you don't want to get in there and already start worrying and figuring out which methods work. But let's move on. They want you to get the area of POSC. Where is POSC? No, POSC, okay? It is P, O, S, and C. So this shape that they want us to deal with, right, looks like it's quite an interesting shape. At first glance, you would be thinking, okay, how do you even work out an area of a shape like this? Now, it being a 5-mark question, it's also one of those things where you almost want to just double check. POSC. POSC. Very interesting. So the thing is, fortunately, you have information in that triangle, you see. Or rather, you have information in this shape. There's an angle there that you have. Don't take it for granted. Like, don't take this angle for granted. The other thing is, this is a 90-degree angle. Don't take it for granted either. Now, all this being said, right, you would probably be thinking to yourself, in this shape, do we have any triangles in there? We don't seem to have any specific triangles. So that situation already puts us in a bit of a tight spot because we don't have any specific triangles in here, but we can make them up. You see, we can make triangles in our shape here, do what we can do, and then I think from there we should be fine. However, obviously the one thought that comes to mind right now is we could probably maybe cut the shape into like different sizes and different shapes and all that. Obviously, if we can do that, I think we will be good. If this was a trapezium, our lives would have been so much easier and like so much better. But it looks like in this kind of a question, we're gonna need to cut the shape and draw our own triangles. So here we have O, right? Here we have S, we got it as like 0 and like -4/3. Now as we're thinking of how to cut this shape, the one thing that comes to mind is I'm thinking of the coordinate of P, we can get it because we have the line DC. So in my opinion, the one thing that I'm thinking of doing is I'm thinking of cutting the shape like this. You see, I'm thinking of cutting the shape like this. The reason I'm thinking of cutting the shape like this is because if you cut it like this, right, you have two triangles that you can work out using the area formula. The area of this triangle here, it doesn't seem like it's going to be a difficult area to find because the area of this triangle, you can say it's half base multiplied by the perpendicular height. This perpendicular height here, you can just use this x value. The distance there is just 2, you see. And then this base here, from here down there, from here to there, the distance there is just 4/3. So you have the distance over there, which is the base. And then this line is the line that has to be perpendicular to the base. So you have half base, right, times the perpendicular height. That's going to be the area of the green triangle. And then what you can also then do is our second triangle here. Its area is also going to be quite straightforward. You can actually, once we have the coordinate of P, right, you can see that this here, you can label this thing all the way down. This can be your perpendicular height. Your perpendicular height here is going to be +3 because the distance from here going straight down is like 3 units. From O all the way to P, it's going to be the length given by the x value of P. So let's get the x value of P first before we carry on with what we're doing. The equation of DC, we worked it out up here. So let's just take that and we need to get its x-intercept. So let's just get that. Getting the x-intercept of CD, let's see here, we can make y a 0. And then here +9. Divide both sides by -3. The x value is a -3. So obviously, since the x value is a -3, it means that the distance from here to there is 3 units. You see? So coincidentally, the perpendicular height and the base are the same, but it doesn't matter. So let's do that. Let's take this green shape here. The green shape, let's actually even copy it here so that we can take it down to where we're going to be doing our calculations. Copy. We're saying here the area of this triangle in particular is going to be half base times height. You see, if you want to rotate it, you can, but it's okay the way it is right now. So here, half. Let's actually use the green so that we can have some kind of a theme here. So let's see here. Yo, what did I just do now? Let's see, go back to the green. Half. Whoa, bro, come on. A half, right? The base here is just 4/3. And then the perpendicular height is a 2. That's the area of this triangle here. This triangle is called COS, triangle COS. Triangle COS. Whoa. Area of triangle COS. Whoa, come on. This is the area of triangle COS, you see. Area. So with that being said, right, let's get this value in the calculator. The value in the calculator here, it's just going to be 4/3, coincidentally. That's the area of triangle COS. The other triangle that we said we have to deal with is this one. See, this triangle over here. So let's copy that. And then dealing with this triangle, its area, we already know it's also going to be half base times height. So this triangle here, the name is just, what do we have there? It's POC, triangle POC. There's P here, O here, C at the bottom, POC. Yep, POC. So area of POC, let's say here area of triangle POC is going to be equal to the following, right? It's going to be equal to a half. The base here is just 3. Perpendicular height there is just 3. It's like 6 divided by 2, so that's a 3. That's the area of triangle POC. So obviously we can just combine those two. POC. So therefore, the area of the shape that they're talking about, POS. No, it's not a triangle, bro. Let's write out area. So the area of POS, area of POSC, going to be equal to 4/3. And then you need to add the 3. All this in the calculator. What? Bro, come on. Let me see what this is giving us. Half base times height. Wait a minute. I feel like I made a mistake here. 1 times 4/3. Yeah, that's fine. Oh, 3 times 3 is a 9. Ha 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 ha. 9/2 is going to be the answer there. 9/2 here. There you go. This added up, you can just check that in your calculator. Let's see. It's giving us 35/6. Let's round it out to 2 decimal places. So getting there, 5.83 units. Whew. Okay, this was quite an interesting question, but we have to keep moving forward to question number 4. Question number 4 looks as follows. It says question number 4, right? Looks like a straightforward question. It says in the diagram, M is the center of the circle having, whoa, we shouldn't be reading only, we should be reading and looking at the sketch. They said M, right? Which is this point here. It is the center of a circle having Pn as its diameter. So them telling us is a diameter, that's important, because now we know at least that this is a 90-degree angle, tangent, perpendicular, radius. And then we now know that these lines are equal. This is the midpoint of these two. So already we're anticipating that if they're going to ask us for P, we can just use the midpoint formula, because we have the middle of the two lines and we have the other side. Let's see, they said KL is a tangent. Yes. We can also anticipate them asking for the equation of the tangent to the circle. That's a straightforward question. And then here they gave us the coordinate of n. And then they said here, we need to calculate the coordinates of P. Oh, that's question number 1. Very predictable. So what we know is, remember, M is the center, right? 3 and -5. This here is the X value of the middle. This here is the Y value of the middle. So what we do know is the following. 3, right, is equal to this, and then -5 is equal to this. So the idea is, in our data, we have the middle, but we also have x1 and y1. We just don't have x2 and y2. Let's put x1 and y1 in the formulas. So in the formula here, we can put x1, right, which is just a 7. 7 plus x2/2. And divide both sides. We can multiply both sides by 2. 6 is equal to 7 plus x2 here. 6 minus 7 is going to be a negative 1. That's the x2. We do the same here. We have y1, right, which is like a negative 2. So here, negative 2, y2 over 2. To get rid of 2, you multiply on both sides, negative 10. And then here, obviously, we want to take the negative to the other side. Negative 10 plus 2 is going to give us negative 8. Oh, this seems accurate. Negative 1 and negative 8. They seem very accurate because this is towards the left, and then this is downward. So you can always just replace this already. Negative 1, negative 8. There we go. 2 marks. And then 4.2.1. Wait, really? Yeah, 4.2.1 says determine the equation of the circle in this format. Determining the equation of our circle is very easy because we have the center, we have the radius also, because it's just going to be the distance mn, of which you could literally just use the distance formula. So in the distance formula, let's see what we have here. Distance, we're going to have here square root. We're going to say 3 minus 7, right? 3 minus 7 squared. The other one, negative 5 minus negative 2. Negative 5 minus negative 2. And then, what do we have here? We have here square root 3 minus 7. That's like a 4. This is going to be a plus, right? Negative 5 plus 2. Like a negative 3. I don't even know, I'm not using the calculator here, but this is going to be 16 plus 9, which is square root of 25, which is just a 5. That is the radius. Seems very believable. So that's okay. Now, that being said, right, we can now say therefore x. So we have to take the opposites, right? So if you see a plus 3 over here on the equation, you have to put a minus 3. And then here, if you see a negative 5, here you have to put plus 5. There you go. That's the way we like it. And then this is equal to, what is it equal to? Let's go to the radius squared. There you go. You can have it like that. That's going to be worth 3 marks. The next thing, they need KL, the equation of KL. That's our equation of our tangent to the circle. Questions like these, I mean, like the tutorials on that, on the main channel, there for you to like learn and all that. So nothing crazy here. Let's see. Firstly, to get the equation of your tangent to this circle, the one thing you want to recognize is that m is just the gradient. You see. Now your gradient, you get it from your radius, because your radius already has 2 coordinates. You're going to get the gradient of the radius, and then you're going to use the formula m1 times m2 equal to negative 1 to get the gradient of KL since they're perpendicular. So getting the gradient of mn, let's actually just do that here. Gradient of mn is going to be negative 2 minus 5. That's going to be a plus. 7 minus 3. That's going to be like what? Negative 2 plus 5. That's like a positive 3. And then it's like a positive 4. And then this is everything to get the gradient of mn. You see, we don't want the gradient of mn. We want the gradient of KL. But then this can help us with that, you see. So the gradient of KL, let's just work it out down here. Gradient of KL, you can just simply say here m1 times m2 equal to negative 1. m1 is like 3 over 4. And then over here we have like m2 negative 1. Divide both sides by 3 over 4. 3 over 4. 3 over 4. You have here 4 over 3. Negative 4 over 3. That's the gradient of the second line, you see, which is the gradient of KL. See, the gradient of KL, just negative 4 over 3. Since you have the gradient of KL, you can easily now use this equation. Y minus y1 equal to m x minus x1. The x1 and the y1, it's the coordinate that your line passes through, which is here, you see, 7 and -2. So that being said, you can say y minus -2. The gradient is what now? The gradient is a -4/3. And then x is like what? Let's see. So there's like -27, right? So the x value is a 7. So let's see here. X value is a +7. So you have to put a +7 over here. Then you have to put a -2 over there. Yeah. And then let's see. This is like, if you multiply inside, that's like -4/3x. And then here it's like what? -28/3. Then this is like y plus 2. Take everything to one side. What are you going to get here? -28 plus the 3. What do we get there? -28 plus the 3. No, minus the 2, sorry. This here, if you minus that also. But then why is this a minus now? This is supposed to be, wait, -7. What just happened for the x value there? Oh, it's a +7. So you put a +7 here, it's going to be a -7. Come on, bro. Come on, because the negative is here. You put a +7 over there. So this is going to be a plus, you see. So this value minus the 2 is going to give you 22/3, according to your calculator. That's all good. That's all nice. We move on. 3 marks. Again, if you need tutorials and lessons on all these topics, you definitely want to sign up for the online courses, because the link to that is in the description. Depending on when you're watching this, probably you might just bump into some kind of a description, some kind of a gift of some sort, but you'll never know unless you go to the link. But anyways, let us carry on. 4.3 says, for which values of k is this equation going to be a secant to the circle? So you see, this is where your theory comes into play, because you want to remember that a secant, right, is going to be, or secant, or whatever you want to call it, it's a line that basically cuts through the circle from one side coming through the other, you see. So it's going to be like something like that, you see. So when they're talking about for which values of k will the circle, no, will this line be a secant to the circle? The one thing you want to just take note of is the fact that the gradient that they are talking about, right, in the question that they have just asked us right now, the gradient that they're talking about, it is the gradient of our tangent here that we are just working on right now. So don't take things like that for granted. These kinds of questions, they work hand in hand with what you would have just answered. So what they're trying to say is, you have a line, right, that has this gradient. So they're asking, what does the value of k need to be? The value of k, remember, it is just the y-intercept. It is just the y-intercept of your line. So you see here, your y-intercept starts by being a value that is up there. So if your y-intercept starts by being a value that is like up there, right, which is like over there, the y-intercept here, we got it to be like 22/3. So this line, the way it is, right, this is a situation where the value of k is 22/3, this particular line. So for this line to be a secant to the circle, it means it needs to be cutting through the circle. So for this line to be cutting through our circle here, this line has to be moved downwards, you see. So this line being moved downwards, you can almost think here, if it moves downwards a bit, you can see here it's now cutting the circle. It's now a secant to the circle. And if you keep moving it downwards, it's always going to be what you may call, it's always going to be cutting your circle at what you call, it's always going to be cutting your circle. So with that in mind, you want to keep in mind that it's always going to be cutting the circle all the way until your y-intercept is like somewhere down here, you see. Now you almost don't know whether it's going to be somewhere down here or not, but it definitely is going to be somewhere down there where the y-intercept is, because if it goes any lower than that, it's not going to be cutting your circle twice anymore. So what you do know is it's a scenario. They're asking for a scenario where your k value is this y-intercept, and they're asking for a scenario where your k value is this y-intercept also. So that's why this question is just a 4-mark question. Well, that's quite a lot of marks because it needs you to know your theory. So k needs to be a y value between this 22/3 and this y value here. So we just have to get what this y value is, which is the y intercept of our circle. The y-intercept of our circle, we can just get that by using our equation of our circle. To get a y-intercept, you have to make x a 0. So that's not a big deal. Let's just make our value of x here 0. See, so making our value of x a 0, we have 0 minus 3 squared, y plus 5 squared, the whole thing equal to 5 squared. Let's see here, 5 squared, right? Now, all this being done, you see, negative 3 squared is like 9. Y times y is like y squared, and then here you're going to get plus 10y plus 25 equal to 25. Nothing crazy there. If you take everything on one side, right, you're going to have y squared plus 10y, and then the 25 minus that 25, you're going to have the plus 9 here equal to 0. Factors of 9 that give a 10, it's just 9 and 1. To get a plus 10, you have to say plus 1 and plus 9. So these are going to be your two answers for y. You see, the y value is going to be either equal to -9, or the y value is going to be equal to -1. So you can see this is the one that's a -1. This is the one that's a -9. So this is where some of your 4 marks are going to come from. So now you're going to need to say that this y-intercept here, right? This y-intercept here, you have to now be careful. It has to be between 22/3 and -9. So you're going to say your k values need to be lower than 22/3, and they need to be bigger than -9. You see, if they can be between those two, then you know that you are good to go. But without, let's say, going on too fast, yeah, it seems like we have what we need. We just need to be careful with these kinds of questions so that we don't like do anything that will just make us lose marks unnecessarily. But then the other thing is, funny enough, this does not seem like it's as accurate as can be. Actually, no. Let's go back. No. The reason why this won't work is because if you look at it nicely, right, this line here, if you look at this particular space here, right, if you're looking at it the way it is, this line can still move downwards and still be cutting the circle twice, only until it is a tangent again, you see. So we have to work out where will our line be a tangent to the circle on the other side. Unfortunately, we know it's going to be a tangent if this is the point that our line passes through. So this equation of this straight line here, we now need to get its equation, because what we actually do need is its y-intercept, which is obviously not a -9. So let's get the y-intercept of a line like this one. A line like this one, its equation will just have a y-intercept of a gradient of -4/3. Reason being, it will be parallel to this side over here. To get this y-intercept here, fortunately, we need a line, or we need a coordinate that the graph passes through. The graph passes through this point. It's -1 and -8. We got that nicely. So y value, we're going to make it -8. X value, we're going to make that -1. Let's see what the other k value would need to be. This is going to be a positive 4 over 3 plus k. And then here, this goes to the left. We're getting the negative 28 over 3 in the calculator. That's your other value of k, right? But to avoid confusion, let's maybe give this a specific variable. Let's maybe even name it, we can even name it q. Q, 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 q. So here, we now know that this here is going to be negative 22 or negative 28 over 3. So since we now know that, we can then now give our final answer for k, right? We can say that our value of k needs to be below 22 over 3, right? Which is that value up here. And it needs to be above negative 28 over 3. Above negative 28 over 3. There we go. So all this being said, we can now move on to 4.4 over there. It's a 2-mark question, nothing crazy. It says point A. A looks like it's a point where the x value and the y value are the same. They are not shown on the diagram. Point A and B are not shown on the diagram. Okay. And then they said here, from point A, another tangent is drawn to touch the circle with the center M at B. But before we get on reading, we might as well get our sketch, because these are the kinds of questions where, even though it's a 2-mark question, one of the things I can definitely suggest for a question like this one, it's only out of 2, but then the way the words are just laid out, it just seems a bit like the kind of a question that's going to need us to just kind of like think. So if these are the kinds of questions where you bump into them and you already start to feel a bit of discomfort, you want to just move on and look at it later. But they said point A and B, they're not on the sketch. Yes, they said from point A, another tangent is drawn to touch the circle with M at B. Show that the length of the tangent AB is given by this equation. So one thing we want to take into consideration is that they said here, this is a point A, this is a point B. From point A to another tangent. From point A, another tangent is drawn to touch this circle with center M. So somewhere along the lines, A, we don't know if it is, it's just a random point. But then from point A, right, you are able to draw a tangent and it will be touching the circle at point B. So somewhere on the circle, there's point B. We don't know where the tangent will be, whether it's like somewhere over here, somewhere over here, it doesn't matter. But what they're telling us is you have a point A somewhere where it meets the circle. You have that as point B. That's what this is saying. Let's see. From point A, another tangent is drawn to touch the circle with center M at B. So this could be the A, but then this would be the B. This could be the A, but then that down there would be the B, you see? Somewhere on this side, this could be your A, but then where the tangent touches the circle, that needs to be your B, you see? That's what these kinds of questions are trying to say. So it doesn't matter what your tangent looks like. What matters is they're asking for the length of AB, right? They said we should show that it is given by this equation. So fortunately, it doesn't matter what the value of A is gonna be. The thing is, the A and the B, they are equal to each other. So if A and B are equal to each other, you have to remember that A and B, this is where you need to be strategic now. If A and B is the same X value and the same Y value, it means that the point A can only be on this line here, you see? Or rather, let's just even finesse the whole thing. Let's just finesse the whole thing. It means that the equation of our tangent is just y is equal to x. Because if point A, right, is a random point somewhere, and B is a point on the circle, the only way point A can be t coordinate t is if the equation of that straight line is just y is equal to x. So by default, you know that this is the tangent that they're talking about. So they're saying show that the length of this tangent is given by this equation. So the length of our tangent here, we may want to be a bit strategic, but not too strategic. We just have to think outside the box. The one thing that comes to mind is here we can draw a right angled triangle, right? We can draw a right angled triangle here. This is going to be the 90-degree angle. Now we have M, we have A, we have B. So if you're going to get the length of AB, you can just maybe use Pythagoras. So this, you can maybe even label it as X and Y. But then, why am I thinking of Pythagoras though? It doesn't make any sense. We could be thinking to ourselves, but then in this situation, we don't have any X or Y values, blah, blah, blah. It's just crazy. But yeah, we can use Pythagoras. So with Pythagoras written out, we know that AM, which is the hypotenuse, is just going to be something we can get. Let's just isolate AB actually. So isolating AB, we have AM squared minus BM squared, right? This is like AB squared. So the AM, we already know we can just say T minus 3. So it's like T minus 3 squared. And then here we have like T minus negative 5. So it's like T plus 5 squared. And then the whole thing, remember the whole thing here, this is the value of AM. The whole thing is squared. So don't take that for granted. That's very, very important. Like, ha, ha, ha. And then, let's see. BM, what we have for BM? BM, we have that as 5. So it's like 5 squared minus is equal to AB. The reason why BM is 5 is because it's just the radius of our circle. So AM, we got it nicely. No. This would have been under a square root symbol because of the distance formula, bro. Come on, stop slacking. So because of the distance formula, you would have had all this, right, under a square root symbol. But then because you're squaring it, the square and the square root would cancel each other out. So let's not forget that. And then it says here, so this cancels that. So we have t squared minus 6t plus 9. Here you're going to have t squared plus 10t plus 25. And then that's like minus 25 equal to ab squared. Fortunately, from here, let's carry on and see what we end up with. So here, it looks like these two cancel out. 2t squared from there, negative 6 plus 10 gives you a 4. And then 9 is the one left there. You're going to have to square root both sides here. Square root. This cancels that. You're going to have here AB is equal to square root of 2t squared plus 4t plus 9. And that's how you're going to get this answer that they asked for. It's nothing crazy, nothing major. Okay, yeah, it was kind of an interesting question, but let's just keep moving. Here it says determine the minimum length of AB. So obviously, I mean, like, it's a paper 2 exam, but it doesn't seem as though you would want to disregard things like differentiation, because one way or the other, if you're going to get the minimum length, you need to get a value of t that causes the minimum length. Fortunately, if you're going to get the minimum length of AB, all you have to worry about is what's under the square root, you see. So if you look at what's under the square root, right, one thing that's for sure is that you're going to need to work out where this is a minimum. You see, where is 2t squared plus 4t plus 9 a minimum? That's your question. So in a situation like that, this is just the quadratic equation, right? So you can actually just think to yourself, to get where this is a minimum, you can just differentiate and equate it to 0. So apart from that, since it's a parabola, you can also just think of this equation, x over negative, bro, minus b over 2a. This can also give you the minimum value of t, because this is also going to be giving you the turning point of the t value of the turning point. So here, to get a value of t that causes the minimum length, can just put here minus 4 over 2. Our a value is a 2. This is like negative 4 over 4. This is like negative 1. So you have 2 here, negative 1 squared, 4 there, negative 1, 9 over there. Let's see, this is going to be the value of t, right? Where you, wait a minute, you have the value of t is a negative 1. So the minimum length is if you throw in negative 1 where t is. So let's see. Anyways, so let's throw in our value of t. It's going to be negative 1 squared plus 4, negative 1 plus 9. In the calculator, let's see what this gives us. So the idea is to make sure that depending on what you're going to put in your calculator, you obviously want to make sure that, I mean, since you've done so much already, the only thing that you can do to lose your marks here is to just put in whatever is in the calculator incorrectly. But then putting everything into the calculator, we're getting here square root of 7. And then you can say you just hit units, you know. Anyways, this was an okay equation. For us to get this negative 1, right, you could have also just differentiated and made your equation equal to 0. It would have given you the same thing, you see. This equation here, if you differentiate it, let's say your first derivative, you would have had the 4t plus 4, made it equal to a 0. The negative 4 would go there, or the 4 would go there, it become a negative. You divide both sides by 4, you get a negative 1. So let's just keep on moving forward to question number 5. Okay, question number 5. So for 2 marks, whatever they're going to ask us, let's see what the question says. It says here, given that this equation here is equal to 0, where our x value is between 0 and 90, let's just try and draw our sketch here. We have our sketch. One way or the other, our sketch has 0 degrees here, 90, 180, 270, and then here 360. So if they're saying that our sketch is between 0 and 90, we know that our sketch has to be somewhere there. However, we know that normally what you do is you want to make sure that your sketch is your given description. You want to put it in a format where your trig ratio is isolated. So from here, we can move the 3 to the other side. You're going to have negative 3 over square root of 13. This is like sine x. Well, already things are looking a bit weird because, I mean, like one way or the other, if you think about it nicely, let's see here, where we're going to put our sketch now. Because the thing is, if your 3 here is a plus, the moment you move to the left, it's going to be a negative. Now, let's see here. So from here, yeah, it's going to be a bit awkward actually, trying to figure out a question like this one, because, I mean, like one or the other, this is like a negative 3. So this is like saying opposite over hypotenuse. So the opposite here is a positive number, positive value. Hypotenuse is also a positive value. So one of these would need to have been different. Let's see, without using a calculator, determine the value of sine 360 plus x. Because I mean, 360 plus x, 360 degrees plus x, this would have just given you sine x. So I mean, like logically speaking, we would say here sine 360 plus x is equal to, since it's equal to sine x, right? It means that it would need to be equal to negative 3 over square root of 13. But the only big issue is this is not making any sense, right? Like it's just not even making any sense because these two are both positives, but then this is a negative. So I'll just put a question mark on this one because it doesn't seem like it's making any sense at all. But this is the only thing that would work. Then here, if they're asking for 10x, what would you do for 10x? Well, okay, so this is just weird, right? Like weird. What's weird about it is the fact that we're dealing with a negative value, but yet here we're dealing with positives. So sure, if you're gonna get 10x, you would have maybe even said, I'm like one way or the other. This doesn't make any sense at all. Hypotenuse, you can maybe say square root of 13 over here. Let's see here, square root of 13. And then here you could maybe have said, it doesn't make sense to have -3 here. It doesn't make no sense. The only thing that would make sense is if maybe this was supposed to be like a plus. I mean a minus. So that when you move it over, this becomes a plus. You see? That's the only thing that makes sense. This would need to be a plus. So yeah, I think for this question, there's probably a mistake somewhere. Depending on who was writing this paper, I think you could have, I think you probably hopefully checked with your examiner or something, because this doesn't make any sense at all. Like error, like what a wow, a big hole in the exam, and we're seeing an error in there. What a wow. What a wow. Anyways, but if we were to use these values just for the fun of it, yeah, it won't make any sense, but let's see. If you're going to get this value, you can use Pythagoras. You could have maybe said square root of 13 squared is equal to weird -3 squared plus, let's say, x squared. Then here you'd have still gotten a 9. This square root would cancel this square root. You'd have had a 13 there. 13 minus 9, that's like 4. Square root both sides. Your x, you can put plus or minus here, which is, no, plus or minus 2. But then this is where things get weird, because I mean, like, we're already seeing negatives on the positive side, but I will take a positive 2 there. So the value of 10 would be opposite over adjacent. So it's like -3 over 2. But then it makes no sense, like no sense at all. No sense. But for the sake of just carrying on with what we're doing right now, let's just carry on. But then this -3 is definitely a mistake, because this is the positive side. So yeah, either this has to be a +3 over 2. I'll just put +3 over 2 actually. Let's just do it like that. The reason I'm going to do it like that is because and I would also probably need to put this as a plus, because on the memo, this may have been seen as a minus, but then on our question paper, it's seen as a plus. So this, yeah, in my opinion, I would even, for some odd reason, argue that we should just alter this question and put a minus over there. That's the only thing we can actually get answers for this question over here. So let's just highlight this error again. Over here, it's supposed to be a plus over there, so I chose to go with this version. The next question, cos 180 plus. 180 plus, right? 180 degrees plus. It doesn't matter. 180 plus is in the quadrant where cos is a negative. So according to our sketch, cos is like adjacent over hypotenuse. So 2 over square root of 3, that kind of works, but then there's a negative there, so that negative has to be there. Okay, that's all good. 5.1 5.2 is where we are now. 5.2 says, but before I move on though, I think I can just emphasize a bit more that there's definitely a mistake over here. So, I mean, whoever is on the, what do they call it? The Department of Education, please do something, because it's definitely wrong. But anyways, let's see. 5.2 says, determine the value of the following expression without using a calculator. So we just need our cast diagram, CAST. But referring to the previous question, I mean, like, those are the kinds of questions where you definitely don't want to dwell too much on those questions, because I mean, like, if you see there's an error, you can ask someone, and then you can just move on. So cos 90 plus is in this quadrant. Everything is a positive, so it's going to be sine theta, because if it's a 90, it changes to a sine. When you have negative, theta minus 180. What I normally do is I swap these around, right? Negative 180 plus theta. And the one thing I do know is, if you're dealing with a minus, you have to go clockwise. So negative 180 means you go clockwise like that. The moment you plus, you have to come back like that. So with all that being said, you can now see that this is the same as negative sine theta, because in this quadrant sine is a negative, you're dealing with 180, so sine remains a sine. So this is like negative sine theta. This here, well, anything with a negative in here, as long as it's not cos, the negative has to go there. There you go. So from here, don't make the mistake of what you call canceling or anything. These are like terms at the bottom. So you can actually end up with like negative 4 sine theta. And then the sines, they cancel out. You have like a quarter over there. And that is going to be your final answer. It's going to be a quarter, a quarter, a quarter, a quarter. But it doesn't matter. Let's move on. The next question here out of 6 says, get the general solution. So this has already been factorized. So, I mean, you're going to take one bracket, make it equal to 0. And then the other bracket, you're going to also make it equal to 0. Excuse me. For the sake of not forgetting the other bracket, let's actually just split up our page in half properly so that we know that one side we do the one question, the other side we do the other side. So here, since this is equal to 0, you want to get at least one variable. So let's maybe, how do you do it? You want to divide, this is looking like we're going to end up with like a 10 or something, you know? So, we're going to have to divide by a cos. So what do we do? It doesn't matter. Let's just take the cos to the other side. I mean, negative cos x here. Divide both sides by cos. You're going to have here 2 tan x equal to negative 1. You want the trig ratio on its own, so you're going to divide both sides by 2. Now, in this situation, remember, since you have a negative value there, it doesn't matter. You have to get a reference angle. You see, your reference angle, you're going to get it from saying shift tan, but then you always have to use a positive value. Whenever you get a reference angle, you have to use a positive value. So shift 10 here with a positive 1/2 is going to give you a reference angle of 26.57. Let's do that. Reference angle 26.57. Now, that being done, you can now use the negative. The negative is trying to tell you have to work in the 2 quadrants where tan is a negative. That's going to be quadrant number 2, quadrant number 4. You see. So quadrant number 2 is 180 minus. You see. So you're going to have to say here quadrant number 2. You're going to say your value of x is equal to 180 degrees minus your reference angle plus k 180 because you're dealing with a tan. Let's see there, plus k 180. And k is the element of integers. You're going to have here x is equal to 153 in the calculator, 0.43 plus k 180. K is the element of integers. There we go. Yeah, so from here you can just get the other answer, which is going to be in the 4th quadrant, right? Yeah, let's see. The 4th quadrant is like this. 4th quadrant is like 360 minus. So it's going to be 360 degrees minus the reference angle plus k. No. Come on. K 180. K is the element of integers. And then, what do we have here? Yeah, everything on one side. Now this minus this is going to give you 333.43 plus k 180. K is the element of integers. There we go. So these are going to be your 2 answers. But then don't forget this as we said, you see. So the 3 sine 2x, right, minus 1 equal to 0. So the 1 has to go over. And then the idea here is to isolate the trig ratio. So divide both sides by 3. Gonna have sine 2x equal to a third. Now don't make the mistake of dividing by 2, because I mean, like, this is stuck together. So you have to get a reference angle. Reference angle, you're gonna get shift sine with a third. Your reference angle here, let's see, shift sine 1/3 is giving us 19.47. The reference angle 19.47. And then obviously, that being the reference angle, you can now say therefore, you have to remember you're working with where sine is a plus. So you're going to say therefore 2x, where is sine a plus? First quadrant and the second one. So in this quadrant, you just take things as they are. 2x is equal to the reference angle. This quadrant number 1, the reference angle plus k360. Okay, the element of integers, 360 plus the 100 and something. I mean, k360 plus the what? No. You have to divide by 2, bro. Come on. Divide everything by 2. You're going to get x. This is just going to be 9.74 plus k180. K is the element of integers. That's quadrant number 1, right? The second quadrant, you have to say 180 minus your reference angle. And then plus k360. K is the element of integers. Now, obviously, here you have to divide by 2 everywhere after you do this calculation, obviously. So this calculation over here is going to give us 160.53 plus k360. K360, k is the element of integers. This is like 2x still. And then the moment you divide by 2 everywhere, these are going to be, this is going to be our answer. X is going to be equal to, in the calculator, divided by 2 here, you have 80.27 plus k180. K is the element of integers. Now, these are all your answers. Nothing crazy, nothing major. You get these answers and you keep things moving. So let us move on to 5.4. Okay, 5.4 says, given this identity, wow, prove the identity. Okay, so to be honest, it doesn't look so bad. The reason why it doesn't look so bad is most identities that have like squares and all that, they just want to hide the obvious. And this is also just a 4-mark question, so that's already a big indicator that we don't have a big problem, because with most trigonometry questions, usually the hard questions start at like at least 6 marks. Actually, paper 2 in general, hard questions started around 6 marks. 5, still moderate. But anyways, let's see. So obviously here, the one thing you want to do is, remember, you do want to work with the side that looks the most complicated. Now this side, for some odd reason, you may assume it's the side that looks the most complicated. And in my honest opinion, that assumption seems like the correct assumption, because this is the one that can be expanded using things like compound angles. This one, yeah, there's already an x there and a y. Yeah, my best bet is on the left-hand side. So let's deal with the left-hand side. The left-hand side, since there's a cos here, you're going to get cos x, cos y. Really? Yeah, let's see. If it's a plus here, it becomes a minus over there. Sine x, sine y. Okay, the more I do this, the more I'm like, uh-oh, did we make the right decision? Let's find out. Then this is like cos x, cos y. Since it's a minus there, there's going to be a plus. Sine x, sine y. Perfect. Let's just multiply. This times this gives you cos squared x, and the y also gets squared. Cos y squared, and then cos x squared. This times this gives us a big line. But then this is actually the difference of 2 squares, you see. There's a minus here, there's a plus over there. So if you have the difference of 2 squares, you can just square this value, get it over there with what you call a minus in the middle. And then you can just square this value also. Sine squared x, sine squared y. This is just the difference of two squares. Because logically you should be seeing something like a minus b, a plus b. You see, that's what we're seeing here. This and this are the same. This and this are the same. There's a minus here, there's a plus over there. So that's the difference of two squares. Because this here can just be simplified to just a squared minus b squared, which is what we did. This here squared and then this here squared. So all those things, look out for them. Judging from where we're going, we need to end up with a 1 somewhere. Ending up with a 1, we may be thinking we need like terms, things that look similar. So there's already a sine squared y here, so let's leave that. This we can maybe change it to cos squared x. And then what? The cos y needs to go, so wow, bro. Wow. Hehehe. Seems like we are busy playing games here. Well, I'm thinking of a way of taking out something common, but yeah, it's just not happening. But it seems like there's no cos anyway, so let's change the cos's, you see? So this is like the cos here. Remember the square identity. The square identity says sine squared x plus cos squared x is equal to 1. So if you leave the cos here, right, it's going to be 1 minus sine squared x. So this is like 1 minus sine squared x. And this also you can say 1 minus sine squared y. And then this is like minus sine x squared. And then sine squared y. Okay, here we could just multiply out 1 times 1 is like 1. 1 times this is negative. This times this is negative that. And then what? This, wait, bro. This times this is this times this is this times this is this times this is a plus sine squared x sine squared y. And then we have minus sine squared x sine squared y. Whoa. Okay, so far so good. We have y here. So the idea is, fortunately, these are like terms. So ka-ching, and then you have 1 minus sine. Let's even start with the x as they did, you see. Let's write this first. Sine squared x, and then this one here, minus sine squared y. There we go. Therefore, left-hand side is equal to the right-hand side. Nothing crazy, nothing major. Let us keep moving forward. Wait. 2 of the same question. Oopsie. Ha. Let's move on. We did that one already. 5.4.2, it says hence or otherwise calculate the value of this. So obviously in this situation, this is where you need to make use of what the left-hand side looked like. You see, because if you use what the left-hand side looks like, it makes your life a bit easier. Or rather, does it? Well, it kind of does. But all I'm trying to showcase here is what this expression looks like, you see. So let's just do this, make this bigger, move this there. So this is the idea, right? It looks like from the way things are, right? The value of 15 here, the 15 here, right, is representing y. And then the 45 is representing x, you see. So if they say it without using a calculator, I mean, like, it looks like using these ones here. Let's just see what would happen. Here you would have 45, here you would have 15. That doesn't help. Here you would have 45, here you would have 15. That doesn't help much. Well, the issue, the funny thing is whenever they say hence, right, you obviously want to use the previous question. But from here, sine 45, we have, actually, no, there's no need to be worrying about anything here. This, we can actually get rid of it. We don't really need it. But let's just take, we already have sine 45. Sine 45 is not an issue. Let's find a way of writing out sine 15. So sine 15 we know it's the same as sine 45 minus 30. You see, now with this is a compound angle of sine, so this is going to be sine 45 cos 30. Since there's a minus here, it's going to be a minus there. Cos 45 sine 30. You see, and then from here we can just use our special triangles. 1 1 no 45 45 1 1 square root of 2, and then the other special triangle is the 30-60 triangle. You see, like that. 30 60, this is like 1 2 square root of 3. There we go. So what we have here is sine 45, right? So sine 45 is just opposite over hypotenuse, 1 over square root of 2, like that. Cos 30 is like adjacent over hypotenuse, it's like square root of 3 over 2. Cos 45 is adjacent over hypotenuse, it's like 1 over square root of 2. Sine 30 is like opposite over hypotenuse, it's like 1 over 2. Square root of 3 over 2 square root of 2, 1 over 2 square root of 2, square root of 3 minus 1, 2 square root of 2. There we go. This is your answer for sine 15. So if it's sine 15 squared, it means that this is squared. It means that everything gets squared. But anyway, sine 15 squared is just this whole thing squared, right? So from here, let's see here. At the bottom, or rather at the top, right, we know that you're going to have square root of 3 minus 1, the whole thing here, square root of 3 minus 1. At the bottom is going to be 2 squared, which is a 4, square root of 2 squared, which is a 2. So you're going to get an 8 at the bottom. Square root of 3 times square root of 3, that's a 3. This times that is negative square root of 3. This time that is another negative square root of 3. And then this time that is a positive 1. So obviously 3 plus 1 is a 4. This minus that is 2 square root of 3. Here it seems like we can take out 2 as a common factor. 2 goes out. You have here square root of 3, the whole thing here, 2 and 4. And the 2 cancel each other out. Whew. Wow, that's a lot. That is actually a lot. And I actually wonder if all that was actually necessary for 3 marks. But anyways, let's see. What do we have here? What are we being asked for? Well, this we don't need, so let me just delete this part, like seriously. So let's see, sine squared 45. What do we have for that? I mean, sine 45 is 1 over square root of 2. So if you square this, it means you square this, meaning you have 1 squared over this squared is just a 2. So this is a half, this we have a value, this is a 1. So our answer is going to be 1 minus this, we got it to be a half, and then this here we got it to be this value here, which is just 2 minus square root of 3, the whole thing over 4. So obviously this we can make it over 1 also. To get the same LCD, this is going to be 2 over 2, this is going to be 4 over 4. We're going to have here 4 minus 2 plus square root of 3, the whole thing over 4. And then 4 minus 2, all these go away. Then you have square root of 3 over 4. Woo! Wow, man. Wow. That is like so amazing. But anyways, let's keep it moving. 5.5.1 says here we should consider the trigonometric expression 16 sine x cos cubed this. Wow. We should write it as a single trigonometric ratio. So obviously the one thing that comes to mind here is taking out a common factor of 8 sine x cos x. Once that is out, here you have 2 left. Here you have cos squared left. Here you have everything gone, right? So minus 1. Fortunately, this looks like the double angle of cos. This has the resemblance of the double angle of sine. If you take out a 4, you're going to have 2 here, sine x, cos x. Here, this is purely the resemblance of the double angle of cos. So you can just put your cos 2x. And then funny enough, this you can change it to sine 2x. This is still just cos 2x. The 4 is still in the front. Funny enough, this all looks like the double angle of sine if you take out a 2. So you're going to have your 2 sine 2x cos 2x. Now what you want to keep in mind is that this and this here is what is going to be at your angle. Because remember, you know that you have a 2 out here. This is going to be equal to sine with the 2 here. And then obviously we have the 2x over here. And then your close bracket over there. So the idea is we know that sine 2 alpha is the same as 2 sine alpha cos alpha. So in our case, what we're saying is where you see alpha over here, we have a 2x. So it's a matter of dropping 2x over here, you see, which is what we have over here. So it's going to be 2 sine 4x. There we go. Much lovely. Woo! Let's keep it going. 5.5.1, no, 5.5.2 says for which values of what? For which value of x within this interval will this expression have its minimum value? Well, obviously what we know is this whole expression is the same as 2 sine 4x. This here will have its minimum value. Well, one way or the other, you have to realize you need to know how this will look visually. This has an amplitude of 2 and it's not been moved up or down. So it's going to go from 2 to -2. The frequency is a 4, meaning in a space of 360 you have 4 graphs. Meaning after 90 degrees you have one graph, then another graph, then another graph, then another graph. Well, this is just what it looks like from 0 to 360. I think let me adjust this so that at least the 2 is like over there, the -2 is like somewhere down there. You see, so the minimum value is equal to -2. That's the lowest value that that graph goes to. So I mean, one more or the other. Let's see. No, the minimum, this goes all the way to like the lowest value is at 2 years. But then the thing is, remember a standard sine graph, right? It would have had its lowest point at 270. So because you have this entire graph here, it was shrunk. So you see in a space of 360, you now have 4 graphs. So instead of having your minimum at 270, you're going to have it at 270 divided by 4, which is going to give you 67.5. The minimum value is equal to -2. However, you get that minimum value where your x value is 67.5. This is within the interval from 0 to 90. So let's move on to question 6. Number 6 looks very interesting. It says, in the diagram below, the graph of f and g, or the graphs of f and g are drawn for the interval. So this here should say interval. For the interval from -180 to +180. And then he says here you have A, and you also have B, 2 points of intersection. Okay, yeah. So the graphs meet somewhere here at B. They meet somewhere here at A. So with all this being done, one way or the other, you want to keep in mind that we need to do the following. So here it says, write down the period of G. So the period of G, where is G? G is the sine graph. So with the sine graph, you have to remember that the sine graph, what is it that we know about the sine graph? The sine graph has a frequency of 2. This is what gives you the frequency. Now you have a formula, right, that says that your period is always equal to, for a sine graph and a cos graph, it's 360 divided by the frequency. So in this situation, frequencies are 2, right? So you have here 180 as your answer. So with all this being done, let's see what we have here. let's see what we also, let's see. So that one is straightforward. The next one is asking us to calculate the value of k. Calculating the value of k is fortunately going to be easy because they're giving us an x value here. You see, x value is 60, this is just the y value. So in any of the two graphs, I would rather go with 10 because it's like straightforward, you see. So here we're going to put 10 in the graph of 10, right? Let's see here. This is just going to be 1060. 1060. Let's see here. We have what we have here. And then this is just there. This is like 30 and 60. 30 is like 1 and 2 square root of 3. 10 is like opposite over adjacent. You see, opposite over adjacent, which is like square root of 3 over 1. It's practically just square root of 3. There we go. So therefore the value of k is equal to square root of 3. So let's keep moving forward. The next question is asking us for the coordinates of b. Getting the coordinates of b, it shouldn't be too bad. Funny enough, it looks as though the x value of the y value of a and b, they're the same. Reason being, you want to see that this image here is repeating over there. So a k value here of square root of 3, we can expect the same for b. So it means that we can actually just take any of our equations and then make them equal to square root of, let's see, I want to take the equation of 10, right? So 10x, let's see here, 10x, where is it equal to? Square root of 3. So here x is going to be shift 10 square root of 3, shift 10 square root of 3, shift 10 square root of 3, that's like 60. So 60 is this value over here, you see. So you want to ask yourself, but if this is 60, how many units far back is the rest going to be? So you want to think of this almost like a general solution kind of question, you see. You want to look at this as like a reference angle. So you're working with where 10 is a positive, right? Or rather, you want to check all the intervals one way or the other. So CAST, what you're going to work with in the first quadrant, you're only going to get 60. So let's try the second quadrant. Or rather, let's see here. This is towards, these are like negative values, but it doesn't matter. It doesn't matter. Let's test out the different intervals. 180 minus this is not going to give us a negative value. 180 plus is not going to give us. So here you can just think of it as, what can we do now? Let's just use what you may call. What we need to use is, we almost need to think of like general solutions. This is just a 1 mark question, so I don't even know why I'm busy here making this such a big deal, because yeah, it's really not necessary. Oh, what we need to do is we need to use symmetry. Like you have to remember the distance from this here, this is like 60, right? And then this is like a 90. So there's a distance here of like 30 degrees. So if this is like negative 90, this is going to be negative 120. So we don't have to do all this because we can just see it by observation that the x value is going to be negative 120. The y value is going to be square root of 3. So let's see here. Let us keep moving forward. Let's see. Let's see. Moving on. They want us to do what now? They want us to write down the range of this expression. So obviously the equation of g is what we need to think of first. The equation of g, what is the equation of g? The equation of g is just 2 sine 2x, you see? So here it's 2 times 2 sine 2x. This is going to be 4 sine 2x, you see? So meaning this graph is going to go as high as like 4. It's going to go as low as like negative 4. And then this is a positive sine graph. The frequency is a 2. So it's going to look something like this, ending off at like 180 degrees. But anyways, all this being said, the range is going to be your y values are bigger or equal to -4. They're smaller or equal to 4. Whoa, bro, come on. Write a bit better, bro. -4. And then here, +4. You see? There we go. Let's see. What do we do now? Let's see. So let's just move on. So with everything being done now, let's see for which values of x will this equation here in this, well, for which values of x will this equation be smaller or equal to 0 in the interval -90 to 0. This is how you interpret this. These graphs have been moved. These graphs, right, have been shifted 5 units left. That's what has happened. So after being moved 5 units left, this is the equation. But the easiest way to look at it is if you take one of them to the other side. You see? So the interpretation here is you almost want to think to yourself where's the graph of G going to be smaller or equal to the graph of F? You want to work this out. Once you have worked this out, your answers move everything 5 units to the left, you see. So let's see where the graph of G has y values that are smaller or equal to the y values of F, you see. So let's see where the graph of G has y values that are smaller than the y values of F. So let's see here, the graph of G, you can see that it has lower y values over here. It has lower y values over here. Well, come on, bro, come on. So I'm saying if you're comparing one, let's just start from the far left, actually, it's easier. So the values of G here that you see they are above the y values of F. Over here, they're the same. From there, here they go lower. And then obviously, until the asymptote, they are lower, you see. At this point here, they are higher. And then here they go lower again. And here they're equal, they go higher. And then here they are lower again until the asymptote. And then obviously, here they are higher. And then here they go lower. So here, we have to be careful. Here we have to be careful. Here we have to be careful. This way, you know, all that symmetry comes to help us, because we say this is like -120, and then this is like also 30 degrees further, so it's like -60. This we got it to be +60. This we got it to be like 120. So the idea is, in a situation like this, you can see that the graph of G is below the graph of F from these intervals here. So with these specific intervals, we want to just get answers but add 5 to all of them. Literally, how many marks is this question? This is a 2-mark question. Oh, they're only talking between -90 and 0. Okay, that makes life a bit easier. Between -90 and 0, it's only this space over here. But then if your graphs are moved 5 degrees to the left, it's going to be at -65 and at -5, you see. So we're going to say there, your x values need to be bigger. Let's see. Yeah, they need to be bigger or equal to -65. And then they need to be smaller than what now? They need to be smaller than or equal to -5. So let's see. What's the thing now? What else? Yeah, this is all good. It doesn't seem like it's a crazy question, this one. That's why it's just 2 marks. The next one says determine the values of p for which this equation will have exactly 2 real roots in this interval. What a wow, bro. What a wow. Well, funny enough, this is, I'm already reminded of the what you call it, the double angle of sine. I'm already reminded of the double angle of sine. If you multiply this side by 2 and you multiply this side by 2, you're gonna have 2p here, right? And then obviously here you're gonna get sine 2x is equal to 2p. And then for you to end up with the equation of sine, you have to multiply by 2 on this side again. And then on this side, you also have to multiply by 2 again, which is going to be 4p. And then this is like 2 sine 2x. And then if you want, let's see, determine the values of p for which this will exactly have 2 real roots. So at this point in time, you have to remember that for this equation to have 2 real roots, you need to consider how the sketch looks. So if you look at how the sketch looks at the moment, it currently has 5 roots in between the space negative 180 to positive 180. So you have there at negative 180. So you have 1, 2, 3, 4, 5 roots so far. Now the only way your graph is going to have 2 real roots is if this part here or this part is your x-intercept, or this part and this part is your x-intercept. Now the only way that's going to happen is if you move your graph a total of 2 units upwards or a total of 2 units downwards, because the amplitude of g is a 2, right? So we know that this graph goes all the way to positive 2, it goes all the way down to like negative 2. So the way this is looking, right, we know that for this equation to have solutions, if you take everything to the without you doing anything crazy, all you need to know is this graph, right? If you have here 2 sine 2x, if you move the 4p to the other side, this is what you have. For this equation to be equal to 0, this part here, right, has to be 2 or negative 2. Because if you move the graph 2 units upwards or you move it downwards 2 units, your graph will only have 2 roots. So here 4p has to be equal to 2, or 4p has to be equal to minus 2. Divide both sides by 4, p here is a half, or p here is a negative a half. There we go. Let's move on to question number 7. Okay, question number 7. So I actually went to question number 7, but for some odd reason, the boy forgot to press record. Yeah, it's painful. But anyways, it says here, A is a vertical flagpole. So we have A over here. And then what? So there's A over here, right? It's a vertical flagpole. And then they said here, it is a vertical flagpole that is square root of 5p meters long. And then it says here AC is, what about AC? They said AC and DC are 2 cables anchoring the flagpole. So you have AC over here, you have AD over there. Okay, that's fine. And then they said here, B, C, and D are the same horizontal plane, are in the same horizontal plane, meaning they're on the ground. B over here, C over there, not D over there. And then they said here, what else the same? They then said here, BD, where is BD? BD here is equal to 2p, that's fine. This whole angle here is equal to x. The whole angle here is equal to 45, so that's okay. And then for 2 marks, they said we should get the length of AD, which is this whole length here in terms of P. So the one thing for sure is that we have a right angled triangle over here, right? And then we have here 2P, we have here square root of 5P, and then obviously up here we have A, AD, and B. And then it says here, what does it say here? AD, so we have to work this out. What you may call using Pythagoras, right? So we know that AD squared, or let's just do where this space down there. AD squared AD squared is equal to AB squared plus BD squared. And then we have here AB is equal to 5P squared. BD is like 2P squared. And then you have AD, which is like just AD. So obviously here square root of 5 squared, that's like 5P squared is P squared. 2 squared is 4, P squared is P squared. And then here you can see these are like terms, 9P squared. And then obviously, since you want AD on its own, we're going to have to square root both sides. Square rooting both sides, we're going to be left with 3P over here, which is our value for AD, as suggested. No. We just have, it is in terms of P, so that's okay. Let's keep moving forward. And then, so the next question here says, we should show that the length of this CD here is given by this expression. So in a situation like this, let's see where CD is. CD is, whoa, where am I going so far now? CD is this line over here. Now it looks as though the best triangle to use is triangle ACD. That looks like the best triangle to use to get CD, right? So let's do ACD. So it's like A, C, and D. Let's do that. So there's A here, C here, D over there, right? And then what? So here AD we got it as 3P. This angle here is 45. This angle here is X. And then what else? We don't have anything else. But then, since they're looking for CD, fortunately what we do know is this angle here is 180 minus these two combined. So let's see, 180 minus the 45 and the X. I think writing it like this for now may be the best. Wink, wink. And then in this situation, it looks like we may have to use the sine rule because we have an angle and the opposite side is missing. Here we have an angle given and the opposite side given. So let's use the sine rule. So we can say here CD of CD over sine what? The angle there is like 180 minus 45 plus X. And then here we have we can say AD over sine C. AD over sine C. And then let's see here. CD, right? What is CD? CD, here you have 180 minus this, right? So that's gonna be 180 minus gives you a positive sign, so it's like 45 plus X. And then sine C, that's like sine X. So it's like AD here and sine X. And then you're gonna cross multiply. But then no, AD, we have something for AD. It's just 3P. 3P. So all that being said, let's see here. Yeah, let's just multiply both sides by the denominator here. So this side, sine 45 plus X multiplied by sine 45 plus X. Excuse me. So this is just going to be CD on its own. And then this is going to be equal to, we're going to need to obviously expand this using compound angles. So expanding this is going to be sine 45 cos X plus cos 45 sine X. Excuse me. And it's like sine X, yeah. And then it looks like at the top, right? We can take out, no. Let's change it to numbers first, and then they'll be the same. Then we can take something out. 1 square root of 2, and then another one square root of 2 over here because of our special triangles. Let's see here, down at the bottom we have sine x. So at the top it looks like we can take out what you may call. Let's see what we're trying to get. Okay, there's a 3p there, yeah, it's fine. Let's take out the 1 over square root of 2 as a common factor. So 1 over square root of 2 times 3p out there, cos x plus sine x. Yo, bro, right nicely, bro. There we go. Now, obviously, for the last step, you can see all that has happened is, you see, because the square root of 2 there, there's a 1 and the square root of 2 down there. Or because you see this number here divided by 1 would just give you sine 3p at the 3p at the top. These two, you can write them swapped around just like how the question wants it. And here you can have your square root of 2 with the sine x. You see, because there's technically a 1 over there, and then there's a square root of 2 over there. There we go. So let's keep it moving. Let's keep it going. So what's the next question now? The next question says it is further given that P is equal to 10, X is equal to 110. Calculate the area of A, DC. So calculating the area of A, DC, right? There's A over here, there's D over here, there's C over there. One thing, let's see what we can do here. So there's X here, right, which is like 110. There's 45 here. This is gonna be 25 because it's like, 135. No, it's 180 minus 110 minus 45. That's gonna give us 25 as the leftovers there. So let's see. We also have AD, which is 3p. So this is gonna be like 30. And then this whole thing here, we have whatever it is that we have, but we don't have to like write it all out for now. Let's maybe just put a tick. So we have CD and we have AD, and we obviously have the angle in the middle. So using the area rule, that's what we can use. So the area of ADC, this is equal to half. So no, half one of the sides that we have is AD. The other side that we have is CD. And then the angle in the middle is like sine 45. Dot sine 45. So that's like sine D. And then this is like a half. AD is like what, 30. CD is like, let's actually get a length for CD before we do things that are just crazy here. Let's see. Copy, paste. We have CD here. There we go. And then P is like 10. 10, 110, 110. And then what we have here, square root of 2 sine 110. So in the calculator, let's see what all this gives us, because obviously it's best to just have this value without it being simplified. So 13.59123.881. So let's put in that information where CD is. Take this value here, copy it, paste it here. Okay, there we go. Close bracket. And then sine D, right? So sine D, where is D? D is D for 5 here. Yeah, there we go. Okay, let's put all this into the calculator. See what we get. So all this into the calculator. Yo, excuse me. I literally have a bottle of water next to me. I should just drink. some war, bar war. Huh. This is like 143 in the calculator. Rounded off 2 decimal places, it's 0.11. That's all good. In the diagram, O is the center of the circle. Okay. And then it says here MNPR. Where's MNPR? There's MNP. That's a cyclic quadrilateral. And then they said here, and SN is a diameter. So SN being a diameter, it means that this is a 90-degree angle. So automatically, if this side is like 64, it means that the other side, according to the calculator, 90 minus 64, it's going to be 26. So might as well put that information over there. And then, yeah, already just by looking at the sketch and knowing your work, if this is 26, this has to be double. So it's like 52, because its angle at the center is double the angle at the circumference. And then what else? Yeah, let's just carry on. Then they said here called MS. There's MS over there, and the radius OR they are just drawn. So you have the radius OR here, and then there's OS, ON, and then MS. So don't take for granted that they've like shown you that OR is the radius. Well, you should know that, but I mean, then mentioning it, that's quite interesting. They then told us that M2 there is equal to 64. We already saw that. And because of the work that you know, or the work that you should know, if the M2 is equal to 64, it means we automatically have P, because opposite angles of a cyclic quadrilateral are supplementary. So if the one side is 64, the other side has to be 180 minus 64. You see, that's like 116. So it's like 116 here. So with this being said, right, they said you determine giving reasons the size of the following angles. The first one is P. 180 minus 64 is equal to 116. The reason for that is opposite angles of a cyclic quad. There we go. 1.1.2, we want M1 now, which is, again, as we said, very simple. We're going to say here M1 is equal to 90 degrees minus 64, which is equal to 26. The reason is angle inside semicircle. You see, because this is an angle inside half a circle. The next one, O1. Wow, look at that. All the angles we actually got. O1, we're going to say it's double 20, is double of 26, which is equal to 52. The reason is angle at center of circle. So this portion is very simple, 3 marks. Then they said here 8.2, right? Guess we're dealing with another diagram. In the diagram, A, B, G. So there's A here, there's B here, and then there's G over there. They said here, they are drawn. This is drawn, right? And they said D and E. G and E are the midpoints. Okay, fine. If these are midpoints, automatically tells you that these lines here are parallel. Furthermore, it tells you that if this is X, this is just double. You see, that's the midpoint theorem that we're seeing here. They're the midpoints of AB and AG respectively. AG, which is this line here, and BG are produced to C. Okay, no. Huh? BG produced to C? I think they meant BF and AG are produced to C. That's the only thing that makes sense. But anyways, it says here, or produced to C and H respectively. Oh yeah, this one goes to H, this one goes to C. Oops. Then it says here F is a point on BC. F, where's F now? There's B and C. Oh, F is there, okay. Then it says these are parallel. So Seems like we're gonna have a lot of proportionality theorem question stuff here. But it says give a reason why DE is parallel to BH. So the reason is just midpoint theorem. Midpoint theorem. And then you can say here BG and BE bisects. What does it bisect now? It bisects AB and AG. AB and AG. There you go. 8.2.2 says, if it is further given that FC over BF is a quarter, the ratio, and they say DE is 3x minus 1, and then GH is x plus 1, calculate with reasons the value of x. So let me just remove this so we don't get confused, you see. But let's just get our sketch a bit closer to where we're going to be writing, because it seems like we need that space. It seems like we need the sketch anyway. So let's just get the sketch here, crop, move this here. Yeah, come on. There we go. So if they said FC and BF, where is FC now? FC is like, FC and BF. Okay, so it's like FC and BF. There we go. It's like this is 1x, 4x. And then it says here, well, let's not use x, let's maybe use like y. 1y, 4y. And then it says here DE is 3x minus 1. So if this is 3x minus 1, this has to be double, which is going to be 6x minus 2 automatically. Then it says here GH is x plus 1. So GH is just x plus 1. Okay. Then it says calculate with reasons the value of x. So, okay. Well, the one thing we can already see is that there's this over this, which is going to be equal to that over that. So let's just say here BG is equal to double whatever DE is. The reason is midpoint theorem. Midpoint theorem, right? So here you have BG, right? It is going to be equal to double. The DE is just 3x minus 1. This is going to be 6x minus 2. So that's how we have this there. And then from there, now we can say that BF, that it will be the FC here, right, over the FC over this BF here, right? The FC over this BF, it is equal to GH over BG. The reason for that is midpoint theorem. No, proportionality theorem. There we go. It's just the proportionality theorem. And then in brackets, you can basically state that GF is parallel to HC. So that being said, you know that this ratio is a quarter. The GH that you have here is just x plus 1. This is just 6x minus 2. So you see here, knowing your theorems, it makes your life so much easier. Here you can cross multiply now. 4x plus 1, 1 times 6x minus 2. And then you have like 4x here plus 4, 6x minus 2. And then 6x minus 4, that's like 2x. Then the 4 plus 2 is like a 6. Divide both sides by 2. X is equal to 3. Perfect. Good marks. It's a 6-mark question. That's okay. Fair. Move on to question number 9 here. 9.1 says, in the diagram, O is the center of the circle. Yes. OD bisects chord AB. Yes, it's a proof question, huh? Prove the theorem that states that the line from the center of a circle that bisects the chord is perpendicular to the chord. Okay. So this one is a straightforward proof, right? So construction, we have to construct OB and OA. So what you're doing is, with these constructions, right, the point is you want to prove that these two triangles are congruent. Now, the moment you prove that the triangles are congruent, you would have proven that this either of the two sides is 90 degrees. So what you do is, congruency, you have to prove that three things are equal but not three angles. So here you're going to say in triangle ADO and triangle BDO, you have the with that being said, ADO and BDO, right? In these two triangles, you're gonna say OA is equal to OB, they're both the radius of the circle, and then you're gonna say AD is equal to BD, that's given, and then lastly OD is equal to OD, that's a common side. So because you have proven that all three sides are equal, you can say therefore ADO, triangle ADO, right, is congruent to triangle BDO. The reason for that is just side. So because they are identical, right, you can safely say that therefore ODA is equal to ODB. So if they're equal, then you can say 180 divided by 2 is equal to 90. So here let's say ODA is equal to ODB. So if that's equal, this has already been proven since the triangles are congruent. Congruent means everything is identical. So you can say therefore ODA is equal to 180 divided by 2. The reason is and goes on a straight line. So because you've proven that one of the sides is a 90-degree angle, you've proven what they're asking you here, you see. So you can almost write it as a conclusion. Therefore, OD is perpendicular to, what is it perpendicular to now? OD is perpendicular to AB. OD is perpendicular to AB. There you go. That's the way we like it. So 9.2, what does 9.2 say now? 9.2 says in the diagram, you have E, you have B, then you have F, you have S. Where's S now? And then you have P, and then these are points on the circle centered at O. GB is a tangent to the circle at B. So automatically, if it's a tangent, it means that this angle is a 90-degree angle. Yeah, it's a tangent at B. And then it says yeah, FE is produced to meet G. Where is FE? FE, yeah, this straight line here. So because these are equal also, that's quite interesting. The moment these are equal to each other, it means that you also have another 90-degree angle here. You see? But let's maybe do it like this. Because a line from the center bisects chord in half, it means this is a 90-degree angle. And then it says here, it is, let's see, FE is produced to meet the tangent at G. So there's a there's a right angle triangle here, then there's another right angle triangle over there. And then it says here, OT is drawn. yes, such that T is the midpoint of EF. And then it says here GO, right? So it's like GO and BO are drawn. BS is drawn. BS here is drawn through T. And then they said here PS is parallel to GF. Okay, that's quite interesting. Let's see what we can do here. Let's keep moving. So here for 5 marks, they said prove giving reasons that OTBG. So it's like OTB. And G, prove that it is a cyclic quadrilateral. So if you're going to prove that something is a cyclic quadrilateral, fortunately here we have, if you're going to prove that something is a cyclic quadrilateral, there are multiple ways to do it, but one of the ways is to prove that, there are multiple ways to do it. You can either prove that opposite angles are supplementary. You can either prove that certain angles within your sketch are equal, maybe like the zigzag effect in your cyclic quadrilateral. And then lastly, you'd want to prove that an exterior angle is equal to the opposite interior angle. So for 5 marks, yeah, also judging from the way this particular question looks, yeah, this is going to be quite interesting. Let's even see. Let me just label it with the red here. There's G, B, there's T, there's O. Okay, now what? Yeah. Oh yeah, this is quite interesting. Well, let's see. We have which lines are parallel here. So we have parallel lines here. Okay, so obviously if this was an exam, this is the kind of a question obviously you'd want to have just moved on, and you make use of the fact that it's a cyclic quadrilateral anyways. But the way it's, okay, I think we have it. Angles here, these are both 90. This angle is 90 degrees. This angle is also 90 degrees. And they are angles that are subtended by the same line, you see. Because it is a 90-degree angle, and it is subtended by the line GO. This is also a 90-degree angle. It is subtended by the line GO, you see. Because remember, with the cyclic quadrilateral, angles in the same segment need to be equal, you see. So that's the route we're going to take. We're going to say GBO is 90, and then we're going to tell them that GTO is also equal to 90. So let's do that. GBO is equal to 90 degrees. The reason is the tangent will always be perpendicular to a radius. And then GTO is equal to 90 degrees also. What do we know? The reason is line from center bisects chord. Line from center bisects chord. There we go. This and this. What else do I need now? Yeah. So as long as you've shown that they're both equal to 90 degrees, right? You can now say, therefore, OTBG is a cyclic quad because angles, because of the converse of the, wait, well, bro, because because of the converse of the angles in the same segment theorem. Because of the converse of the angles in the same segment theorem. So in other words, if you're going to say something like converse, you're almost trying to say you are seeing the law using other means in your sketch, you see. So here it is clear that angles in the same segment are equal since they're being subtended by the same line here. So it means that because of that, a circle can be drawn around all those points over there. That's basically the idea behind all that we'll be saying over here. So let's just carry on from here based on all this information that we have gathered. Moving on, right? Let's see what we can do here. So from here, now that we've proven that we're dealing with the cyclic quad, let's see if there's anything else. They said we should prove that G O B is equal to S. Where is G O B? Where is G O B now? G, and then there's O, and there's B. So that angle, they said we should prove that it is equal to angle S. That's very interesting. GOB, prove that it is equal to angle S. Angle S is what is angle S? Angle S is this one, and let's see here. GOB is this one. There we go. So, well, whew, how many marks? So if you look at my reaction, right? My reaction should give you the idea of how you go about these kinds of questions. It's a 4-mark question. Yeah, it is what it is. Let's see what we can do. 4-mark question. So moving on with this 4-mark question, let's see what we can do. So the only thing that it seems like we can do here, what can we do? Wow. Okay, yeah, we have alternating angles here. So let's maybe focus on that. This angle here is equal to S. So how can we then show that this angle is equal to that one? Yeah, that's quite interesting. Like, wow, bro, like that is super interesting. But since it's a cyclic quadrilateral, let's try and see if we can find something to help us. I mean, like cyclic quadrilaterals, we know that opposite angles are going to be, there's an exterior angle is equal to an exterior is equal to the opposite interior angle. But sure, the way this is looking, it just looks so crazy. Like, whoa. Prove that. Let's go back. GOB. Make sure I'm using that. GOB. Prove that it is equal to angle S. Well, without wasting any time, right? Let's just write out what we have so far, like the fact that S is equal to FTS. So let's just do that. S is equal to FTS. The reason for that is what is the reason again? Alternating angles. Okay, there we go. Alternating angles. So with that being said, right? Let's see if something is equal to FTS. Something equal to FTS. Let's maybe even clean up our sketch a bit just to try and see. FTS. Oh, vertical opposites. So FTS is equal to, oh, perfect, bro. You see what we did there? Cleaning up the image, shed a bit more light. because this angle here, right, is equal to that one because they are angles in the same segment. They're both subtended by GB. So this is equal to that because of vertical opposites. Let's just tell them first. So that's gonna be what? Is that's ETB is equal to the angle we just spoke about now, which is FTS. So ETB is equal to FTS. That's vertical opposites. Vertical opposites. Vertical opposites. And then what do we have now? What do we have? Yeah, the ETB, we can say it's equal to GOB. You see, ETB is equal to GOB. The reason for that is angles in the same segment. In the same segment. There we go. So, all things considered, we have said that this is equal to GOB, this is equal to FTS, and FST is equal to S. So we can say therefore, GOB is equal to S. That's a conclusion, basically, because you can trace it. This is equal to that, this is equal to that, and this is equal to S. They're all equal to each other. Now we can move on to question number 10. Okay, question number 10 seems like we're gonna have a good time. Because there's just so many things going on as it seems. But let's see. It says in the diagram we have a cyclic quadrilateral. It is P, it is Q, it is R, it is S. It's a cyclic quadrilateral. And then it says here KP, yeah, is a tangent to the circle at P. Yeah. Well, we have the 10 chord theorem, obviously, then. Do we? Yeah, this one is going to be equal to that one because of the 10 chord theorem. So let's maybe use dots. No, let's just use what we're using. Let me maybe remove these dots here because, no, let's maybe leave them. Cyclic quadrilateral. But anyways, while you're filling in information, if you see that your sketch is the way this is looking, right, seems like there's a lot going on. And it's going to be easy for us to like just randomly put out just a lot of useless information on what you call on our sketch. But anyways, this is the 10 chord theorem. And then they say we have a cyclic quadrilateral here, so we should think of laws of a cyclic quadrilateral and all that. Then it says here, yeah, it's a tangent C and D. Where is C and D? There's C here, there's D here. Are points on the chords. Then there's C and D are points on chords PQ. Where's PQ? PQ and PS respectively. And let's see here. CD produced meets RS at A. Then they told us all these things here. This is parallel. Let's see which ones are parallel. It's CA, right? So CA is parallel to QS. Where is CA now? CA parallel to QS. And then it says here P1 is equal to R2. Okay, that's important. P1, where is P1 now? Yeah, P1 is here. Okay, so that's important because if they're going to tell us that those are equal, they said equal to R2, right? It automatically means that this is also equal to this one. We should not forget it. They're all equal to each other, those ones. Because if this is equal to this, because of the 10 chord theorem, these are equal. They just told us they're equal. It's like given information. So we can just use that information to our advantage. So it seems like there's a lot going on here. They say we should prove that S1 is equal to T2. So So before even looking at the sketch yet, anytime you need to find out or you need to prove that two angles are equal to each other, focus on each of them individually, like finding easy things that they are each individually equal to. Let's see S1 and T2. There's S1 here, and there is T2 here. So it seems like quite a stretch to just go from here to there. But let's find something S1 is equal to. S1 is bluntly equal to the whole angle over there. Does that seem like that's going to help? To be honest, it doesn't seem like it, but yeah, ne? You gotta do what you gotta do. But then before just jumping there, let's see what T2 is equal to. T2 is equal to the other side, but that side is not even labeled anyway, so you don't even want to worry about that. How many marks? It's a 4-mark question. So it's a 4-mark question. Obviously, in an exam, at this point in time, I would have probably moved on to come back to it later, because it's not like a easily and directly straightforward question. It seems like there's some friction, you know? So, I mean, if push does come to shove, right? The one thing that you definitely do want to do with situations like this is you just basically want to, what is this? You just want to write out what you can, write out what you can, write out what you see. So let's even start with what we're saying. S1 is going to be equal to Q. The reason is exterior angle of cyclic quadrilateral. The cyclic quadrilateral, right? Let's see, maybe color coded. Let's move this so that we don't get confused. Let's see here. So we have this here equal to that whole thing over there. And we're trying to show that it is equal to this part over here. So what you do is, let's look for something that this whole angle is equal to. And I mean, we're thinking to ourselves, okay, what do we have? We really don't have much, huh? T2. Wow, man. Okay, the RCPT Dr. Cape Town does not seem to be helping us much. Let's see in this cyclic quadrilateral if we have angles in the same segment. Anyway, we don't have tangent. We already spoke about that. Parallel lines. This angle is equal to that one. Yeah. So to say that this is equal to that directly, yeah, that's gonna be a bit tricky. But let's see if we can find something else equal to S1 for some odd reason. Well, we have parallel lines here, so I mean, like, let's see what we can do. Okay, so let's maybe see this is equal to that, and it is equal to that. Okay, let's see this angle here. We said it is equal to that part, right? And it is also equal to that part. So I guess that's kind of interesting. Those are equal. S2 is equal to P1 because, what do you call it? Alternating angles. But then in this cyclic quadrilateral, we do have angles in the same segment over there. I'm only noticing now. No, we don't. That's not angles in the same segment. Even though they're equal. It's clearly just a coincidence. Yeah, this question is not very straightforward. But that's why I mentioned that with this kind of a question, I would have moved on a long time ago. Because there's really no need for you to be what you call, for you to be spending too much time on a question that you just cannot see what's going on. But anyways, let's just try and see if we can just maybe get something going in this question. So what can we do? So it looks like we're gonna need to use some combination of angles, because that's the only thing that seems like it's gonna work now. So we say this is equal to that whole thing. So let's just write it out like that. You see, this is equal to Q1 plus Q2. Let's write it out like that. Q1 plus Q2. And then what else do we know? We also know that S2 is equal to Q1, but how is that useful in any way? Yeah, that's quite interesting. That is quite interesting. That is quite interesting. Yeah, that is quite interesting. But then obviously the thing is, there is a saying that says where there's fuel, there's definitely fire. So let's see here. Let's see what we can do. Let us see what we can do. So if you look at what we have, right? We have been given the okay. Okay, yeah. So it looks as though we're obviously gonna need to think outside the box with this kind of a question. So with S1, right, we said it is equal to Q1 plus Q2. And then with T2, what we also do know is, since it's an exterior angle of R2 and Q2, and then R2 is equal to Q1. So yeah, let's go that route. So here, let's say T2 is equal to R2 plus Q2. The reason is just exterior angle of a triangle. And then R2, right? Remember, R2 is equal to Q1. We need to tell them we know that because they told us that R2 is equal to P1. And then P1, we need to tell them that it is equal to Q1 because of the 10 chord theorem. Let's just state all those things. So P1 is equal to Q1. Reason is 10 chord theorem. 10 chord theorem. And then we need to say that therefore Q1 is equal to R2. Or rather, before mentioning this, we can say that P1 is equal to R2. That's a given. You see? So since Q1 is equal to P1 and P1 is equal to R2, it means they're equal to each other. So that's a conclusion. So it means from here you can then write, therefore, T2 is equal to, where you see R2 here, you can just put Q1 plus, and then here you can put Q2. So here you can say, therefore, S1 is equal to T2 because they are both equal to Q1 plus Q2. There we go. So that's another way of working out or showing that two angles are equal. You can show that them combined is equal to the same thing, or they're equal to two angles combined. Anyways, more practices and more lessons that are in detail, right? You can find that on the course platform. The link to that is in the description, because one way or the other, you need to somewhat have a system when you work out these kinds of questions. But let's move on to question 10.2 now. 10.2, we obviously need our sketch. But let's see. It's a 5-mark question, so that's going to be interesting. Let's see what we can do here. Paste. Highball. Hey, when's in Johnny? Like, what's going on? When's in John? Highball. I keep doing the same damn thing. Come on, bro. Come on, man. Come on. Come on. Do something. Do something, my guy. Thank you, yo. So, anyways, we have our sketch here. We have to be careful what it is that they're gonna ask us. So let's see. There's AD. Where is AD? Highball. It will be AD. Oh, it's from here to there. And then you have AR. AR is from here to there. And then AS. AS is from there to there. Okay. Then you have AC. AC is from there all the way to there. Oh, okay. It seems like we're dealing with this triangle here. These two. For the proportionality theorem. Seems like we're gonna have to deal with these two here. There's R right over there. And then there's this line here, parallel line. We have S here, T here, see here, A over there. There you go. And these lines are parallel. There we go. So all this being done, yeah, we have to be careful one way or the other because you don't wanna just go overboard. But anyways, they spoke of AS, they spoke of AC, they spoke of AR. The only thing they didn't speak of is like the only thing that's not in this sketch is AD. But then AD forms part of like AC. So we can definitely do something there. Anyways, for 5 marks, they said we should what? We should prove the following. Okay, we should prove that this is equal to that. So this is gonna be interesting. Well, we can start off by thinking of just let's see, we can just start off by thinking of the what? The proportionality theorem. So we can say here, since we have AR, let's see AS and AC. Yo, goodness, bro, goodness. Do we maybe need to prove that certain triangles are similar? Let's maybe try and see if certain triangles can be similar here. There's this triangle here, and there's this one over here, yo, 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 yo. Let's see if it can work out, right? The ASD. Let's try out ASD and the big one. Let's see if there's a way that they're similar. I think they should be because they already have a common angle, which is A. So let's see here. And then here, the big one over there. And then yo. There we go. Whew. Yeah, ne? So let's see what's going on here. I mean, one way or the other, we have a common angle, right? Yeah, that let's see which angles we said are equal to each other. S1, we proved it to be equal to like T2. Yo, let's see if there's anything we can salvage. Because if we can prove that these are similar, okay, this is a common angle, fine. We already know that this angle here is equal to that one. Yes. And it is also equal to that one because of alternating angles. Yeah. So we can prove that those two triangles are similar because we have two sets of angles that are equal to each other. So the two triangles we're dealing with, it's triangle ASD, A, S, and D. The other one is the big one, which is A, R, and C. You see? C here, R here, A over there. So this is a common angle, the A's. And then we're also going to eventually prove that angle S over there, right, is equal to angle C over here. And then we're proving that they're similar, and we can easily write this out. So let's do that. You see, so we have to state the fact that these two have already been proven to be equal. So now we can just say T2 is equal to C2, right? The reason is alternating angles. Alternating angles, right? And then you can now state that, what can you now state? Whoa. Yeah, therefore C2 is equal to S1. You see, therefore C2 is equal to S1. That's more like that's more of a conclusion. But before writing all this, we can firstly state that we're talking about specific triangles, you know? So we can say here in triangle, let's call it ASD, and triangle, let's see, ASD, right? And ACR. In these triangles, we know that we stated what we stated here. That's the first thing. And then the next thing we can just say angle A is equal to angle A, common angle. And then lastly, we can state that this angle here is equal to that angle there. So I can say here A RC is equal to ADS. The reason we can just say interior angles of a triangle. There we go. So all that being done, we can then say therefore they are similar to each other. I see. Triangle ASD is similar to triangle ACR. So that being done, we can now say the following here. We can now say something like what? We can now say something like AS over AC. AS over AC is equal to SD over CR. SD over CR, which is equal to AD over AR. There we go. And then what do we have now? The reason for writing this, you can just say proportionality theorem. So now we just want to pick out the different lengths that are already also here. You see, so we need AD somewhere. Check. We need AR somewhere. We need AC and AS. There we go. You see, AS over AC is equal to AD over AR. Then you're gonna get your 5 marks there. 5 good marks. Thank you very much. Let's move on to 10.3. It's a 4-mark question. We need to prove this. So obviously proving something like this, the one thing that I normally try to do is, since this is already multiplied together, let's try and have it as a ratio because it's easier to see what's going on. You can start off by dividing both sides by SD. You're gonna have AR, TC, SD. We just chose any random one. Doesn't matter which one you started with. So once we have done this, we're trying to end up with a ratio. You see? So here we can maybe then divide both sides by AR. So divide here by AR, divide here by AR. We're gonna have your AC, the whole thing over AR. And obviously on this side here, AR cancels that. We have TC over SD. So this is what we could be looking to prove, you see. So it's a 4-mark question, so we don't have to like panic or anything like that. We also maybe might need to use the expression that we have proven in the previous, or rather we might have to make use of the fact that we have certain angles, certain triangles that we've proven to be similar, but we'll see. So here, let's look at the lines we're talking about. We're talking about AC, which is the whole thing there, AR, which is the whole thing there, and then TC is just this part here. Okay, perfect. And then SD, for some odd reason, it's just like randomly there. Wow. So I was thinking of what you may call of the proportionality theorem between what you may call these triangles, right? But then you can see that the SD there is the one thing that's just ruining everything, because it's like, where does that even fit in, That's the question. Now the question would be, is it a line that is equal to any other line or something like that, blah blah blah. So that's obviously something to look out for. So in a situation like this, you would almost just be glad that this is something that we're seeing right at the end of the paper, because I'm like, the way it looks, it just doesn't look very very fun, but at the same time, you then want to think of scenarios where you can maybe have a triangle that has the line that you're talking about, because in situations like these, yeah, you definitely do need, in some instances, triangles that have that line that we're talking about there. So let's look at the triangles that we have just worked with. They already do have DS. So let's check our expression here. because this whole expression here at least has ds somewhere, so we can also start there. We maybe remove just that paste here. So based on the question that they're asking us, right, let's see which of these lines we can actually reuse. You see, there's AC, AR, SD, wow. Well, now it's a bit tricky because you're probably wondering, do we use these two here or do we use those two? Now, the other thing is, in the expression we've just proven, there is already SD somewhere and AC also. No, is there? The expression we were asked to prove, let's see. Yeah, there's no SD anyway, so yeah, we can just hold on on that. But what do we have? Let's just see. Where's AD? AD is just there. And CR is like that line over there. AS is that line over there. Okay, so yeah. At this point in time, you'd be wondering what to use, because definitely probably the SD over the CR, that one is a definite. The only question is what do you use now, But let's see what you have here. You have AR and TC. AR. I think something with AR might help, because I mean, like the part that is AC, there's AS over there. AS, AC might be more useful, because I mean AC already has AD in there somewhere. So yeah, this is where you can see that. Yeah, this is where it becomes a bit difficult, just a bit deciding like what to use. You see, but at the same time, you don't want to just stay in the same place for too long, because if you stay in the same place for too long, that's when you start to miss it. So the one thing that we're at the end of the question, right, but we haven't exactly yet made use of the fact that we have these parallel lines here. So the one way we can incorporate these parallel lines is if we try to think of the proportionality theorem for our big triangle. Now, in our big triangle, our big triangle has the sides SR. It also has TC somewhere over there. So let's see what we can do, because here we have, let's see, SD, and we have CR that we have spoken about. Yeah, SD, and then there's CR, blah blah blah. Let's see what we can do here. Why am I having such a blunt moment now? Because obviously the way I'm trying to work this out, I'm trying to work it out systematically, or rather to use a method that you can almost repeat for similar questions, because we don't want to just do things randomly. We want to have an idea of like, okay, where do we even start with something like this if we have to like prove this 10.3. So we said we're starting somewhere here, right? But then obviously maybe if we're looking at this expression here, SDAS, AR, and TC, let's just see what we know. What we know is these two triangles here, right? The small one here and the big one. We know we can have many different expressions based on whatever it is that we may need. So I mean, almost as like well, you don't want to think to yourself that this is a question where you like have to almost think of like a scenario where you just like choose like some kind of, you don't want to choose randomly, right? So let's see here, what would justify choosing AD over AR? Choosing AD over AR, those are two lines on two separate sides, but then AS and AC, it's also the same thing, two lines on two separate sides. Yeah, see, Mashabella. Yeah, gotta think. AR, and let's see here, TC, AS, and SD also. yada yada yada. Okay, yeah, this is quite interesting, but let's see what we can do, right? Let's maybe go back to our main expression over there. You see, there is the AS, the AC times SD, then there's the AR and TC. Using this to make sense. The reason is with AD, right? AD does not necessarily form part of this image here. You see, because you have this long line there, and then you have this there, right? And then you have this there. So here you have S, then you have R, there's T over there, there's C over here, then there's A. So obviously in a situation like this, you don't want to work with points that are not on this image. You see, of which AD is one of those things where there's A and D and somewhere there. So it doesn't really work when it comes to the proportionality theorem. So between choosing you going with this and this and you going with this and this, you can see going with this is easier because there's at least AC over there and there's AS over there. So let's go with these two. Going with those two, you're going to have AS over AC is equal to SD over CR, right? So since you want to end up with SD and CR, okay, let's see. From here, you can maybe just cross multiply. We're going to have SD times AC equal to AS times CR. Let's see what we're trying to prove. SD and AS. Okay, so we have SD and AS here equal to this thing here. Perfect. Let's label this equation number 1. So since we already have, let's just maybe flip this over or maybe write it exactly like this so that we can, have our confidence boosted a little bit. AC dot SD. So we have one thing, one side. But then our AC and SD is not equal to AR and TC. So let's see. AR and TC, we can get an expression from here. That is AR and TC. So what can we say? AR, we want AR and TC some way, somehow. So, okay, that's gonna be quite interesting. AS and CR. Well, it seems like there's AS and CR here. There's AS, CR, and then there's TC. And yeah, it looks like if you take the whole AR, it goes with CR. And if you take AS, it goes with TC. So let's do that, you see? So in this expression here, we're going to say, looks like we have to take this, right? Maybe this over that is the same as the TC over the CR. Let's write that down. So in another expression, AS over AR is equal to TC over CR. If you cross multiply, you're going to have AS times CR equal to TC times AR. So the fortunate thing is this is also AS and CR, just like what we have over there. So it means these are also equal to each other, you see, which is the TC and the AR over there. You see, so since they're both equal to the same expression, it means that they're equal to each other. You see, so you can conclude and say, therefore, AC dot SD is equal to TC dot AR. There you go. There we go. Nice, nice, nice. These 4 marks, they were not the most fun 4 marks in the paper, but this paper was relatively fair, in my opinion. Nothing too crazy. It was basically up to standard. If you knew your theory with this kind of a paper, I guess you're okay. And obviously, one way to make sure that you're able to tackle these kinds of exams is to sign up for the online courses on our website. The main idea with online courses on our website is that obviously you go through the entire syllabus all in one place without needing to worry about any additional material. One of the things that I can also say is, I mean, like things like the online courses, right? In a space of 24 to 48 hours, you'll be done with the entire syllabus. So this is just a sale that's currently ongoing as of this recording. But obviously the sale as of this recording is actually, whichever way, you'll find out how much the all access pass is. The all access pass gives you access to the entire syllabus all in one place. But anyways, from my side, I will catch you in the next video. Don't forget to subscribe. The main channel, Bright Young Brains, has tutorials that are more like bite-sized tutorials that you will be able to go through from time to time to refresh your knowledge. There's also specific videos, pointers, tips, and so many things that may interest you. Obviously, in addition to tutorial videos over there. But anyways, let me not. I'll catch you in the next video.